A dolphin hunting in dark water doesn't see its prey, it hears its shape. It fires clicks from an organ in its forehead, called the melon, which focuses sound into a tight beam. Those clicks bounce off a fish and return as echoes, and the dolphin reads the delay to judge distance. A longer wait means a farther target. It catches those echoes not through its ears, but through its lower jaw, where fatty channels carry the sound straight to the inner ear. The whole ocean becomes a map drawn in returning sound. Quantum theory is staggeringly precise. It predicts a certain magnetic property of the electron to a dozen decimal places, confirmed by experiment. Yet apply that same theory to gravity and it falls apart. The calculations balloon into infinities that no trick can fully remove. The method that tames infinities for other forces simply fails for gravity, because gravity grows stronger at the very scales where the quantum chaos is wildest, feeding back on itself. So the most accurate theory ever built cannot be extended to the most familiar force. Nearly every atom of gold in existence was forged in catastrophe. Stars fuse hydrogen into helium, then heavier elements, but the building stalls at iron because fusing iron drains energy instead of releasing it. So how do we get gold, platinum, uranium? In the violence of collapsing stars and colliding neutron stars, free neutrons flood in faster than atoms can decay, building heavier and heavier nuclei. The ring on a finger carries metal assembled in some of the most extreme events the cosmos allows. Heat a metal rod and it glows. First dull red, then orange, then a brilliant white blue if you could push it far enough. The color reports the temperature, and the reason is pure physics. A warm object radiates light, and the hotter it gets, the more its glow shifts towards shorter, bluer wavelengths. Cool embers sit in the red. The sun's surface, far hotter, peaks in yellow-white. This is why a star's color reveals its heat from across the galaxy. Red stars are the cool ones, blue the fierce. Temperature has a color, and every glowing thing. Type Ia supernovae explode with such consistent brightness that astronomers use them as cosmic measuring sticks. The reason lies in their trigger. Each begins as a white dwarf that pulls matter from a companion until it nears that universal mass ceiling. Reaching the same critical point, the stars detonate with nearly the same energy every time. Because we know their true brightness, comparing it to how faint they appear reveals their distance, letting us map the scale of the universe. Healthy bone heals a clean break without leaving a seam, and the secret is that it doesn't patch the gap so much as grow across it. After a fracture, a clot forms, then a soft bridge of cartilage spans the break. Bone-building cells invade that bridge, replacing it with new bone and forming a bulky lump called a callus. But it doesn't stop there. Over months, the same crews that remodel all your bones whittle the callus down, dissolving excess and reshaping along the lines of stress. The healed bone becomes nearly indistinguishable. To learn the depth in the seabed at once, sailors dropped a line with a hollow in its lead weight. Lowering the weighted rope until it touched bottom gave the depth. Read off marks tied along the line. But the clever part was the cavity at the lead's base, smeared with sticky tallow. When it struck the floor, sand, shell, or mud pressed into the grease and rode up to the surface. A navigator near an unfamiliar coast could feel his depth and read the bottom. Gravel here, fine sand there, and know roughly where he was. Twist a pair of sunglasses and you'll see glare shift. That's polarized light, light whose waves vibrate along one axis. We're nearly blind to it. The mantis shrimp is not, and it reads a rare twisting form called circular polarization that almost nothing else in nature detects. Its eyes carry a built-in filter that converts that spiral light into a signal its receptors can catch. Some mantis shrimp even flash circularly polarized patterns on their bodies, sending private messages on a channel their predators simply cannot tune into. Press gently at the corner of a closed eye in the dark, and a spot of light appears where there is none. The eye can't tell what kind of energy struck it. It only knows its cells were triggered, and any trigger reads as light. Pressure, a knock to the head, even electrical static can fire those cells, and the brain faithfully reports light. This reveals a deeper rule. A nerve doesn't carry the nature of a stimulus, only the fact that it fired. What you experience depends not on what hit the cell, but on which cell was hit. Approach a black hole, and the sky behind it warps into a ring. Light from the stars directly beyond the hole cannot pass through, so it bends around the edge instead, curving along the steep slope of space. Rays that would have missed you are steered into your eye, and the hole becomes a lens, smearing the background into bright arcs. You can even see the same star twice, its light routed around opposite sides. Gravity does not block the view. It rearranges it, painting a halo of bent starlight around a circle of absolute black. Plutarch told how a Spartan, mocked for his city short sword, replied that it reached the enemy well enough. The blade was small because the man closed the distance himself. Brevity, he meant, is no weakness when you bring your courage to it. A short life, lived close to what matters, can reach further than a long one held at arm's length from everything. When a giant star dies, its core collapses in less than a second, falling inward at a quarter the speed of light. The unfouling matter slams into the newborn neutron core and rebounds, and a flood of ghostly particles called neutrinos pours outward. Almost all of them pass straight through the star, but enough push back to blow the outer layers apart. That rebound and neutrino blast is a supernova, briefly outshining an entire galaxy of 100 billion stars. The softest thing in the world dashes against and overcomes the hardest, the Tao Te Ching says. That which has no substantial existence enters where there is no crevice. Lao Tzu means water and air and quiet. Think of a draft finding the hairline gap under a door. Formless, it goes where the rigid never could. Happiness depends upon ourselves. Aristotle builds his entire ethics toward this in the Nicomachean Ethics. Happiness for him is not luck or pleasure, but eudaimonia, living well by acting in accord with reason and virtue over a whole life. Because it rests on how you act and not on what befalls you, it lies largely in your hands. Not a feeling that arrives, but a life that is practiced into being. The strength of Roman concrete in the sea was not a recipe they fully understood. It was a slow gift of chemistry that revealed itself over centuries. When they mixed volcanic ash, lime, and seawater, the reaction did not finish on the day it set. For hundreds of years afterward, seawater kept seeping in, kept dissolving ash, and kept growing new interlocking minerals inside the material. The concrete was, in a sense, never finished curing. It used the ocean as a slow forge, becoming a little tougher with every passing tide. Where a river meets the sea, fresh and salt water refuse to mix easily. Fresh water is lighter, so it slides out over the top, while denser seawater wedges underneath in a hidden tongue called a salt wedge. The boundary between them stays surprisingly sharp. As the river falls and rises with the tide, that wedge pushes inland and retreats. A river mouth is not one body of water, but two, layered by their weight. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the sea. The bones of a sunken whale can power life for years after the flesh is gone, and the trick is hidden inside them. Whale bones are soaked in fat, and specialized worms and bacteria break that fat down for energy. Some bacteria even produce a chemical that other creatures, in turn, feed upon. So a skeleton becomes a slow-burning engine, releasing stored energy long after the body has vanished, feeding a community built entirely on the riches locked inside the dead. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. On a heaving deck, a sailor could not write fast enough to track every change of course, so he poked holes in a board. The traverse board was a wooden disc carrying a compass rose, with a peg pushed into a hole for each half hour to record the headings sailed. Below, more pegs logged the speed. At watch's end, the pattern of holes told the whole story of the last 4 hours. A bird crossing an ocean cannot stop to ask where it is. So many migrants run several compasses at once and cross-check them. The stars give one heading, the setting sun gives another, the magnetic field gives a third. If one cue drifts, the others catch the error. It is if one cue drifts, the others catch the error. It is the same logic a careful navigator uses with Plutarch warned against the appetite that never closes. To hunger fed on getting only sharpens. The cure is not a fuller plate, but a quieter anywhere at all. Toward a black hole, and it appears to tick slower and slower, never quite reaching the edge. Near the horizon, the effect grows without limit. Light from the clock stretches redder. This is nothing strange. Its own seconds pass normally. Two truths, both real. It should. Light takes time to reach the retina, and the signal takes this delay by predicting where moving things will be by the time you're aware of them. and showing you that future position, placing the world where it's about to be. Push past it, and the star cannot survive. White dwarfs are held up by the pressure, forced to move near light speed, where they can resist no further. Gravity wins and the star. The first element's heavier than hydrogen. The entire cosmos acted as a fusion reactor, binding protons and neutrons into helium. Every atom beyond lithium had to wait for the first stars to live, die, and seed space. The Egyptians divided the night by watching stars rise. Split the day into 12 as well, giving 24 divisions total, the ancestor of our hours, cut into 12 no matter their length. A summer daylight hour was simply longer than a winter one. Do not step twice into the same rivers, for fresh waters are ever flowing in upon you. So the banks hold still, the shape seems fixed, the name stays the same. Yet the substance, everything passing through it is replaced. Hold some things wrong and some right. Heraclitus suspected that our judgments of order and discipline, a star tearing itself apart, is also a forge that makes the heavier elements, scattering. Gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob encoded real astronomical cycles in metal. The ratios chosen so the wheels turned over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. Your inner ear knows up from down without your eyes. Below the spinning canals sit two small chambers holding a jelly studded with tiny crystals of calcium. When you tilt your head, gravity drags those crystals, bending sensory hairs beneath them and reporting the lean. The same organ senses straight-line acceleration, the push back into a seat as a vehicle speeds up. Shut your eyes in motion and you still feel the tilt and surge. Stones the size of dust grains keep you oriented to the pull of the world. An hourglass cannot tell you the time. It can only tell you that a fixed amount of time has passed, because the sand always takes the same span to fall. That is the secret of every early timekeeper, not reading the moment, but measuring a steady interval. Water clocks work the same way, draining at a constant rate. The deep problem these devices solved was that the sun fails at night and on cloudy days. To keep time in the dark, people needed a process that did not care about the sky, only about flowing at a dependable pace. Light bends when it passes a mass, the way a heavy ball dimples a stretched sheet. So a galaxy cluster sitting between us and a distant galaxy can warp that far light into arcs and rings. Measure the bending and you can weigh whatever is doing the warping. Again and again, the lensing reveals far more mass than all the glowing stars gas combined. The extra weight is invisible, yet it curves gas combined. The extra weight is invisible, yet it curves space. Inside the beak of some birds sit grains of magnetite, a naturally magnetic mineral, giving the bird a sense of magnetic intensity, like a built-in gauge of how strong the field is in a given place. Since field strength changes across the globe, It may serve as a kind of altitude reading on a map made of magnetism. The journey of 1,000 li commenced with a single step, the Tao Te Ching reminds us. Lao Tzu shrinks the impossible to one footfall. For a figure adrift between worlds, the distance is unthinkable, yet it crosses only ever the small stretch of space directly ahead. Most of the atoms in your body were forged inside stars and scattered by their deaths into clouds like the ones we drift past. Carbon, oxygen, iron, none of them existed when the universe began. They were cooked in stellar cores, then flung outward when those stars exploded or shed their outer layers. That enriched gas seeded new clouds, which collapsed into new stars and planets. You are, and the line between them is matter passing through. The Milky Way is not a flat plate. It's warped like a vinyl record left in the sun. The outer disk bends up on one side and down on the other. The likely cause is gravity from smaller galaxies orbiting and passing through, tugging the loosely held outskirts where our galaxy's grip is weakest. The dense inner disk stays flat. Only the thin edges flex, so the shape of our home is not fixed. It is gently, constantly bent by the company it keeps in the dark. The calcium in your bones and the iron in your blood were cooked inside stars that died before the sun was born. Lighter elements like carbon and oxygen form in the fusion furnaces of aging stars. Heavier ones are scattered when those stars explode, seeding clouds of gas with fresh ingredients. From such enriched clouds, new stars and planets form. You are quite literally assembled from the ash of earlier stellar deaths, a fact that links your body to events billions of years gone. Some stars you admire tonight may no longer exist. Light from a distant sun can take thousands of years to cross the gap to Earth. If such a star burned out a millennium ago, its final light is still in transit, still painting a point on your sky. You would go on seeing it shine faithfully until that last wave of light swept past. The star is gone, but its image lingers, a candle whose flame we still watch long after the wick is cold. There is an old discipline, Marcus Aurelius said himself, almost a recipe. Look round at the courses of the stars as if thou wert going along with them. The idea was practical. Trace something immense and orderly, and the small frictions of the day lose their grip. He called it purging the filth of earthly life. Up here, that exercise needs no effort. The stars are already going along with us. Each night, the brain appears to weaken many of its connections slightly, scaling down the strength that built up during the day. Without this, synapses would grow ever stronger until the system saturated and learned nothing new. By turning the volume down across the board while preserving the strongest signals, sleep keeps the important and discards the noise. So forgetting is not always a failure. You wake with a clearer mind, not only because you rested, but because the brain spent the night quietly forgetting on purpose. Inside a dying, massive star, the elements arrange themselves like the layers of an onion. The reason is temperature. The core is hottest, so it fuses the heaviest fuels, building up to iron at the center. Surrounding shells, each cooler than the one within, fuse progressively lighter elements: silicon, oxygen, carbon, helium, hydrogen at the outside. The star burns through these layers in a desperate, accelerating sequence. The final stages lasting mere days before the core gives way and collapses. Stars far heavier than the sun end their lives by collapsing into black holes, but only the most massive ones. When such a star runs out of fuel, nothing remains to hold up its core against its own weight. Gravity wins completely, crushing the core past every known limit until not even light escapes the point it reaches. Lighter stars stop at a dense ember. Only the heavyweights fall all the way through. The same force that lit the star for ages now closes over it. A black hole is, quite literally, the corpse of a giant that could no longer hold itself up. Wonder is the only beginning of philosophy. Plato gives that line to Socrates in the dialogue Theaetetus. The idea is that thinking does not start with an answer. It starts with being stopped in your tracks. A question you cannot shake is the doorway. Drift past a slow-turning world and feel that small jolt. That is the feeling he meant. Wonder is not the decoration on knowledge. It is the engine that sets the whole search in motion. Comets grow their glowing tails only as they near the sun, and those tails always point away from it, no matter which way the comet travels. A comet is a ball of ice and dust. Sunlight warms it and turns its ice straight to gas, releasing dust into space. Then the sun's outflowing wind and light push that material outward. So a comet racing away from the sun flies tail first, its bright streamer pointing ahead of it, always swept downwind of the star that lit it. Mountains have roots, and the roots explain why the peaks last. Thick continental crust is lighter than the mantle beneath it, so it floats, the way an iceberg floats with most of its mass submerged. Pile up a mountain range, and you also push a deep keel of light rock down into the mantle to balance it. As wind and rain wear the summit away, the buoyant root slowly pushes the whole range upward to compensate. So a mountain can keep standing tall for ages, refloating itself even as erosion tries to grind it flat. Type Ia supernovae explode with such consistent brightness that astronomers use them as cosmic measuring sticks. The reason lies in their trigger. Each begins as a white dwarf that pulls matter from a companion until it nears that universal mass ceiling. Reaching the same critical point, the stars detonate with nearly the same energy every time. Because we know their true brightness, comparing it to how faint they appear reveals their distance, letting us map the scale of the universe. Nearly every atom of gold in existence was forged in catastrophe. Stars fuse hydrogen into helium, then heavier elements, but the building stalls at iron, because fusing iron drains energy instead of releasing it. So how do we get gold, platinum, uranium? In the violence of collapsing stars and colliding neutron stars, free neutrons flood in faster than atoms can decay, building heavier and heavier nuclei. The ring on a finger carries metal assembled in some of the most extreme events the cosmos allows. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world. The first time you meet a new pathogen, your defense is slow. Days to find the right antibody. The second time, it's fast. The reason is a small population of memory cells left behind after the first encounter, each already tuned to that specific invader. They sit quietly for years, sometimes a lifetime, doing nothing. Then the same threat returns and they multiply at once, flooding the body with the exact weapon needed. Immunity isn't a wall built around you. It's a memory carried inside specialized cells. Deep ocean trenches and towering mountains are often two faces of the same event. Where an ocean plate dives beneath a continent, it carves a trench at the point of descent, the lowest place around. But just inland, the same collision crumples and lifts the continental edge into high peaks. So the greatest depth and a great height sit side by side, separated by a relatively short distance, both produced by one plate sliding under another. The planet's most extreme topography tends to gather right along these boundaries, because that is where the crust is most violently worked. Double a black hole's mass, and you exactly double the width of its shadow. The event horizon scales straight in line with mass, because gravity's reach grows in simple step with how much sits inside. This makes the giant strangely roomy. The most massive holes, billions of times heavier than the sun, can have horizons spanning the scale of a planet's orbit. Yet the curve of space across them is gentle. Bigger holes are paradoxically less violent at the edge. Mass and size march together, one for one. A rare clean ratio in a universe that loves to complicate. Fjords are valleys that the sea moved into. During the ice ages, glaciers ground their way to the coast, and where the ice was thickest, it carved the rock deeper than the level of the ocean itself. When the climate warmed and the ice retreated, seawater poured into those over-deepened troughs. The result is a flooded glacial valley, sheer walls plunging straight underwater, often deeper near the middle than at the mouth. That shallow lip at the entrance marks where the glacier finally lost its strength and stopped carving the floor below the waves. A particular kind of exploding star always detonates with nearly the same brilliance, and that makes it a cosmic yardstick. These stars ignite only when a dead stellar core crosses a fixed mass threshold, so each blast releases a similar burst of light. Knowing the true output, astronomers read the apparent faintness to gauge enormous distances, measuring the reach of the universe one explosion at a time. The fairest universe is but a heap of rubbish piled up at random. Heraclitus meant that order. Looked at closely is built from the unplanned. The cosmos agrees. Planets assembled from a disk of drifting debris, grain colliding with grain, no blueprint anywhere. And out of that random piling came worlds round enough to hold an ocean. Beauty here is leftover dust that happened to fall together. Deep in the brain sits a cluster of cells no larger than a grain of rice, the body's master clock. It takes a direct cable from the eye, separate from sight, that reports only how bright the world is. At dusk, as that signal fades, the clock orders a nearby gland to release melatonin, the hormone that tells every organ night has come. This is why screen light late at night confuses sleep. The eye reads the glow as daylight, and the clock holds the hormone back. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. A tall tree lifts water higher than any pump could push it, and the trick is tension, not pressure. Inside the leaves, water evaporates from tiny pores, and each escaping molecule tugs on the one behind it. Because water molecules cling together, that pull travels down an unbroken thread, all the way from root to crown. The tree never lifts the water. It simply lets the air pull and refuses to let the chain break. So a column of water hangs under tension, stretched like an invisible wire reaching tens of twinkling stars, and a steady shining planet reveals something about distance. A star is so far away it arrives as a single point of light, and pockets of moving air bend that pinpoint beam this way and that, making it flicker. A planet, though tiny in the sky, sits near enough to show a small disk. That disk is many points at once, and their flickers average out. So if a light holds rock steady, you are likely watching a world, not a sun. When a giant star dies, its core collapses in less than a second, falling inward at 1/4 the speed of light. The unfouling matter slams into the newborn neutron core and rebounds, and a flood of ghostly particles called neutrinos pours outward. Almost all of them pass straight through the star, but enough push back to blow the outer layers apart. That rebound and neutrino blast is a supernova, briefly outshining an entire galaxy of 100 billion stars. Much of your immune system sits wrapped around your gut. It seems excessive until you remember what the gut is: a long tube open to the outside world, lined with food and trillions of microbes. The body's largest meeting point with the outside isn't your skin. It's this inner surface, folded to a surprisingly vast area. So the immune system stations much of its forces there, learning constantly which microbes are tenants and which are threats. The deepest border you patrol runs through the middle of you. On the summit of a peak miles above the sea, you can pick up a stone holding the spiral shell of a sea creature. It is not a trick of the eye. That rock formed on an ancient ocean floor, layer by layer from shells and mud. Then the slow shove of colliding continents lifted the whole seabed skyward and folded it into a mountain. The fossil never climbed. The ground beneath it rose, carrying a fragment of a vanished sea up into the thin, cold air. The roots of a forest are wired together by threads thinner than hair. Underground fungi weave through the soil and fuse with tree roots, trading mineral nutrients they pull from the dirt for sugars the trees make from sunlight. This fungal web also links separate trees, letting them shuttle carbon and chemical signals from one to another. A seedling shaded on the forest floor can be fed through this network by larger neighbors. What looks like a competition of trunks is also, quietly, a shared circulatory system buried in the ground. Eat more fiber, and you're not just feeding yourself. You're feeding a city. Plant fibers pass undigested into the large intestine, where gut bacteria ferment them and release short-chain fatty acids. One of these, butyrate, becomes a preferred fuel for the cells lining your colon. So the cells of your own gut wall are partly powered by waste products of the microbes living inside it. Your inner surface runs on an exchange. You deliver the fiber, the microbes convert it, and the lining burns what they leave behind. Almost every large galaxy hides a supermassive black hole at its core, and the hole's mass tracks the galaxy around it. The bigger the central bulge of stars, the heavier the hole, in a steady proportion. This is strange because the hole is tiny compared to the galaxy, far too small to govern its outer stars directly. Yet they grew up together, feeding and shaping each other across cosmic time. The link tells us black holes are not lonely oddities tucked in corners. They are partners in how galaxies are built, woven into the story from the start. Light from a far cosmic explosion arrives stretched and delayed compared to a closer one, and that difference reveals expansion. Light from a nearby blast comes through quickly. Light from a distant one is lengthened by the growing space it crosses. By comparing how stretched the light is against how distant the source must be, astronomers chart how the cosmos has expanded across its long history. Seneca compared a crowded, scattered life to a vessel that cannot hold what is poured in. No matter how much you give it, he warned, it runs straight through. The loss is in the leaking, not the supply. A mine pulled in every direction keeps nothing. It is not the quantity of time that fails us, but the container. Out here, undistracted, the present finally stops running out the bottom. Cut the bridge between the two halves of a brain, and you may get two centers of awareness in one skull. In rare cases where the connecting fibers between the hemispheres are surgically divided, each half can process the world separately. Show an object only to the left visual field, and the right hand draws it while the speaking left hemisphere honestly denies seeing anything. The person feels like oneself, yet behaves like two. This unsettling result suggests unity of mind is not given. It is something the connected brain continuously constructs. Down is only a direction we agreed to fear. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world. And some of the oldest rock on land is far older than any rock on the ocean floor, and that gap is a clue to how the planet works. Continents are made of light rock that resists sinking, so they ride on the surface for billions of years. Ocean floor is dense, and dense rock eventually dives back into the mantle and melts away. So the seabed is constantly destroyed and remade, never lasting long, while the continents endure. The Earth keeps its lightest material on top and quietly swallows the rest again and again across deep time. The night sky is not a snapshot. It is a collage stitched from 1,000 different eras. One star's light is a few years old, another's a few thousand, a faint galaxy's a billion. Each point arrives having traveled its own distance, so each shows its own moment in the past. You are never seeing the universe as it is. You are seeing a layered archive, every pixel time-stamped by how far it had to come, all of it landing in your eye at once. The Tau in its regular course does nothing, and so there is nothing which it does not do. That is the Tao Te Ching's quiet paradox. Lao Tzu calls it Wu Wei, action without strain. Gravity works the same way. It never pushes, never hurries, and still it steers whole galaxies through the night. Magnetic stripes are frozen into the ocean floor, and reading them proves the sea floor spreads. Now and then, the Earth's magnetic field flips, north and south trading places. Molten rock erupting at a mid-ocean ridge records whatever direction the field points as it hardens. As new crust forms and drifts outward, it carries that frozen compass reading with it. The result is a pattern of parallel bands, normal, reversed, normal, mirrored on both sides of the ridge. Those matching stripes are a tape recording of the seafloor being made, played outward from the seam in both directions. Nature does nothing in vain. Aristotle repeats this across his biology, watching how every organ seems fitted to a function. He overreached at times. Nature has no plans. Yet the instinct was sound. Ask what a part is for, and you understand the animal. It made him one of the first true naturalists, dissecting, comparing, cataloging. Look closely at any living thing, he taught, and you will find form answering to purpose. A single teaspoon of neutron star matter would weigh about as much as a mountain. Here is why. When a massive star's core collapses, gravity crushes protons and electrons together into neutrons, packing them as tightly as the particles inside an atomic nucleus. Ordinary matter is mostly empty space between tiny nuclei. Strip that emptiness away, and you get a substance so dense that a sugar cube portion holds the mass of a small range of hills. The whole star, heavier than the sun, fits inside a sphere the width of a city. A supernova can briefly release more energy than the sun will emit across its entire 10 billion year lifetime. The source is gravitational collapse. When a massive core falls inward, an immense store of gravitational energy is suddenly liberated, most of it carried away by neutrinos in seconds. Only a small fraction becomes visible light, yet even that sliver can outshine a whole galaxy. For a few weeks, a single exploding star can be seen across vast stretches of the universe. Drop a pebble in a still pond, and ripples spread outward in neat circles. You will never see ripples converge inward and spit out a pebble, though the wave equations permit exactly that. This is the arrow of radiation, another face of time's direction. The outgoing wave is favored not by law, but by setup. It is staggeringly hard to arrange the precise inward motion the reverse would require. So waves, like heat in broken glass, run one way for the same statistical reason. Everywhere we look, time's flow turns out to be improbability. Black holes are not eternal. According to quantum theory, they slowly leak particles at their edge and shrink, an effect called Hawking radiation. The mechanism is subtle. The boundary between something and nothing is not perfectly clean, and energy can escape as a faint glow. Smaller holes glow hotter and vanish faster. The largest take longer than the present age of the universe by numbers too vast to picture. But the principle stands. Even the darkest objects evaporate, given enough time. Nothing in the cosmos, not even a black hole, is true. In the saltiest pools on Earth, evaporation can outpace the rain so badly that the water begins to grow gardens of crystal. As brine concentrates past its limit, the dissolved salt has nowhere to stay but solid form, so it precipitates into the water, building delicate cubes and crusts on the bottom and along the shore. Some pools rim themselves with rings of white that thicken by the day. The water is not just salty, it is saturated, holding all it possibly can, and quietly handing the rest back as stone. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Most of the helium and carbon you encounter began inside stars through a process of patient assembly. In stellar cores, hydrogen nuclei fuse into helium, and in older stars, 3 helium nuclei collide to form carbon. This stepwise building of heavier elements from lighter ones is how the cosmos grew chemically rich. The earliest universe held almost nothing but hydrogen and helium. Everything more complex, including the carbon in every living thing, was manufactured by generations of stars. Asked where he came from, Diogenes answered, "I am a citizen of the world." The word he coined, cosmopolites, refused the small loyalties of one city's walls. Belonging, he insisted, is as wide as you dare to make it. Seen from far enough out, every border on a planet vanishes into a single pale curve, and the whole sphere becomes the only homeland there ever was. Hair grows for years, then stops on a hidden schedule built into the follicle. Each hair on your head follows a cycle, a long growing phase lasting several years, a brief shutdown, then a resting phase where the hair sits quietly anchored before it finally releases. The follicle is the timer, and because each one runs on its own clock, you shed only scattered hairs, not all at once. Underneath, stem cells in the follicle wake and rebuild a new shaft from scratch. Every long hair is the output of a tiny organ that grows, pauses, and resets over and over. On a riverbed in flood season, you may find smooth round holes drilled into solid rock. These are potholes, and pebbles carve them. A swirling eddy traps a hard stone in a hollow and spins it, and the trapped stone grinds against the bedrock like a drill bit. Over years, it bores a deepening cylindrical pit, sometimes large enough to stand in. The river itself is too soft to cut stone, so it lets the stones it carries do the cutting for it. The greatest wealth is to live content with little. The line reflects Socrates, who walked Athens barefoot and refused payment for his teaching. His logic, every desire you do not need is a master you do not have. Wanting less is its own kind of freedom, harder to lose than gold. Strip a life down to what it truly requires, and you find how little that is and how much room is left over. The expanding universe stretches old light as it travels, painting distant galaxies redder than they truly burn. As space itself grows during the journey, each light wave is pulled longer, shifting its color toward red. Measure that shift and you measure both distance and the age of the view. The deepest, faintest galaxies glow most strongly red, betraying both their vast remoteness and the eons their light has crossed. The color of ancient starlight has been reddened by the very journey it made. The matter spiraling into a black hole releases energy far more efficiently than the fusion that powers stars. As gas falls through the steep gravity, it surrenders a large fraction of its mass as a pure radiation, a much greater share than burning hydrogen ever yields. That is why feeding black holes shine so fiercely. The light is the toll matter pays to fall in. Deep gravity wells convert mass into energy with brutal effectiveness. Pound for pound, nothing lights the cosmos more economically than something simply falling toward a place it can never leave. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world. Watch a storm and a strange truth arrives. Light wins the race and it isn't close. Lightning and thunder are born in the same instant, the same channel of ripped open air. But light travels at roughly 300,000 kilometers per second, while sound crawls at about 1/3 of a kilometer per second. So the flash reaches your eyes almost the moment it happens, and the thunder lags far behind. Count the seconds between them, divide by 3, and you have the distance to the strike in kilometers. The delay isn't a quirk, it's the gap between two speeds made visible. Some acacia trees in Africa hire armies and pay them in room and board. The tree grows hollow, swollen thorns and drips sugary nectar, and in return, aggressive ants move in. The ants swarm any animal that bites the leaves and even prune away rival plants that crowd their tree. Strip the ants away, and the defenseless acacia is quickly chewed back. The thorns were never just armor. They are barracks, and the tree's true defense is a standing army it feeds every single day. Marcus Aurelius left a small reminder about how little of the world we actually occupy. He urged himself to consider how small a part of the whole substance he was, and on how small a clod of the whole earth he crept. The point was scale, honestly faced. Knowing your size doesn't shrink you, it cures the illusion of being central. The drifting figure here is one small part, fully at home in the vast. Your two ears are spaced a hand's width apart, and that small gap is how you find a sound in space. When something calls from your left, the wave reaches your left ear a fraction of a millisecond before the right and arrives a touch louder since your head casts a faint sound shadow. Your brain reads these tiny differences in timing and loudness and computes a direction. It's why a sound directly ahead, equal in both ears, is the hardest to place, and why tilting your head, changing the gap, helps you pin it down. A white dwarf the size of Earth can be hotter than the surface of the sun, yet it produces no energy at all. The heat is left over. Having ceased all fusion, a white dwarf is simply the exposed, glowing core of a dead star, cooling like an iron pulled from a forge. Because it is so small and dense, it radiates that stored warmth slowly. The faintest, coolest of these embers have been cooling for nearly the entire age of the universe and have barely gone dark. Our sun will not explode. It will quietly shrink into a white dwarf, an ember the size of Earth holding nearly half the sun's mass. The reason is mass. Only stars far heavier collapse violently. When the sun exhausts its fuel, it sheds its outer layers and leaves behind its dense core. No more fusion holds it up. Instead, a quantum rule, the pressure of tightly packed electrons refusing to share the same state, props it against gravity. It will simply cool, fading over billions of years. Grow, reproduce, use energy, evolve. Name what living things do, and every rule leaks. Fire grows and consumes. Crystals replicate a pattern a mule can't reproduce. Each line we draw lets something slip across it or admits an imposter. And this isn't a gap waiting to be filled with a cleverer sentence. It hints that life may be a gradual thing, not a switch, that there is no agreed scientific definition of life, because the boundary we keep searching for between chemistry and biology, the universe is comprehensible, and that is the most incredible thing about it. The eternal mystery of the world is its comprehensibility. Why did a single perfume bind Arabia to Rome? Frankincense is hardened tree sap, and the tree that makes it, Boswellia, grows in only a narrow band of dry highlands in southern Arabia and the Horn of Africa. Cut its bark and it weeps a milky resin that dries into amber tears, prized for burning. Because the tree refuses to grow elsewhere, anyone wanting that smoke had to trade for it. Scarcity drawn by climate became a road. The incense route ran for the simple reason that the plant would not travel. When a giant star dies, its core collapses in less than a second, falling inward at a quarter the speed of light. The infouling matter slams into the newborn neutron core and rebounds, and a flood of ghostly particles called neutrinos pours outward. Almost all of them pass straight through the star, but enough push back to blow the outer layers apart. That rebound and neutrino blast is a supernova, briefly outshining an entire galaxy of 100 billion stars. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler, and every glance into a small step back in time. The world reaches your senses already slightly out of date. Light arrives almost at once, but the nerve signal from a stubbed toe crawls up the leg and takes longer to reach the brain than the flash of seeing it happen. So the brain quietly waits, holding the faster signals back, then assembles them into a single moment that feels seamless and now. Present time is a construction, stitched from inputs that arrived at different speeds. What you call this instant is the brain's best guess, edited to hide the lag. A particular kind of exploding star always detonates with nearly the same brilliance, and that makes it a cosmic yardstick. These stars ignite only when a dead stellar core crosses a fixed mass threshold, so each blast releases a similar burst of light. Knowing the true output, astronomers read the apparent faintness to gauge enormous distances, measuring the reach of the universe one explosion at a time. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited up. He fell through the silence until the silence became a song. Sagittarius A, the giant at our galaxy's center, is over 4 million solar masses. Yet its horizon would fit comfortably inside the orbit of Mercury. That is the strange economy of black holes. All that mass collapses into a region smaller than a single planetary path. Pack enough weight into a small enough space, and gravity seals it off behind a horizon. The bigger the mass, the wider that horizon grows, but always far tighter than the spread of stars around it. A whole galaxy turns around a dark coin no broader than the inner solar system. A Polynesian navigator carries no compass, yet steers by one drawn entirely in the mind. The trick is that every bright star rises at the same point on the eastern horizon, night after night, and sets at the matching point in the west. Divide the horizon into named houses, learn which star climbs out of which house, and the sky becomes a dial. You aim the canoe at a star low ahead. When it lifts too high, you switch to the next one rising behind it. A dozen stars in the right order can hold a heading straight through the dark. Some places have not felt real rain in living memory, and the cause is a cold current just offshore. Along parts of the Atacama in Chile, the sea is chilled by water rising from the deep. Cold sea cools the air above it, and cool air holds little moisture. That heavy, stable air refuses to climb and rain. Add a wall of mountains blocking storms from the other side, and the rain almost never comes. Some weather stations there have logged years with no measurable rainfall at all. Fog drifts in from the ocean, yet the ground stays bone dry. Inside a dying, massive star, the elements arrange themselves like the layers of an onion. The reason is temperature. The core is hottest, so it fuses the heaviest fuels, building up to iron at the center. Surrounding shells, each cooler than the one within, fuse progressively lighter elements. silicon, oxygen, carbon, helium, hydrogen at the outside. The star burns through these layers in a desperate, accelerating sequence, the final stages lasting mere days before the core gives way and collapses. Some sleepers learn to know they are dreaming and can signal out from inside the dream. In this lucid state, the dreamer realizes the world around them is generated by their own mind. Researchers reach such dreamers by agreeing on eye movements in advance. Since dreaming sleep leaves the eyes free to move, the sleeper answered with deliberate glances, a message from within a dream. It suggests dreams are not pure chaos, but a state the conscious mind can sometimes inhabit and steer, a rare bridge between the inner theater and the watching world. Lightning strikes a tall tree or a metal mast not because it aims, but because height shortens the gap. As the leader descends, the ground below crowds with opposite charge, and that charge concentrates most densely on the highest, sharpest points. Sharp points pile field lines tightly, so the air there breaks down first and launches an upward spark to meet the bolt. The tree does not attract lightning so much as it offers the descending channel a shorter, easier last step. Distance, not desire, decides a strike. A black hole is described by just 3 numbers: its mass, its spin, and its electric charge. Nothing else survives. Throw in a star, a planet, a library of books. Once it crosses the horizon, every detail of what it was is erased from the outside. Physicists call this the no-hair principle, the idea that black holes have no distinguishing features. 2 holes with the same mass, spin, and charge are truly identical, however differently they form. The cosmos keeps an astonishingly short record. Plato pictures the soul as a charioteer steering 2 horses, one noble, one wild. The image runs through the Phaedrus, and it redraws what freedom means. Freedom is not letting the wild horse run. That is to be dragged wherever appetite goes. It is the reasoned self holding the reins. To master yourself in this view is the only way to actually be your own. Stand in a desert and the ground may be hot enough to cook on, yet the night can leave you shivering. Water is the missing blanket. Humid air and clouds trap heat and release it slowly, but dry desert air holds almost none. With nothing overhead to hold the warmth, the day's heat radiates straight back to space the moment the sun sets. The temperature can swing dozens of degrees between afternoon and dawn. The same emptiness that makes a desert burn by day is what makes it freeze by night. For a Polynesian navigator, the destination never moved. The world flowed past it. In the mental picture used on long voyages, the canoe sits still while the starting island slides away behind, and the target island draws near ahead, and reference islands off to the side glide by to mark progress. Tracking those passing references against the star path, let the navigator judge distance covered without any instrument. It is a profound shift of viewpoint, not a small craft crawling across a vast sea, but a still center around which an entire ocean is carefully reeled. Deep glacier ice glows blue, and the reason is hidden in sunlight itself. White light is a blend of every color, and water is very slightly tinted. It absorbs red light more readily than blue. In a thin sliver of ice, you would never notice. But sunlight pushing through meters of dense, bubble-free glacier ice loses almost all its red along the way. What finally escapes back to your eye is what is left over the blue. The older and more compressed the ice, the deeper that blue becomes, as if the glacier has been straining the warmth out of the light. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world, and most of the planet's volcanoes are arranged in a single vast ring around the Pacific. This is not coincidence, but geometry. The edges of the Pacific Basin are lines where ocean plates plunge beneath their neighbors. Each subducting slab drags water down, melts the mantle above it, and feeds a chain of volcanoes along the coastline. Trace those chains and they connect into an almost continuous loop, the Ring of Fire. The pattern on the map is simply the pattern where the sea floor is diving back into the earth. Cold doesn't exist as a thing that flows. There is no substance called cold streaming into your hands on a winter day. Temperature is just the motion of atoms, jiggling faster when hot, slower when cold. Heat only ever moves one direction on its own, from more motion to less. So when you feel cold, what's truly happening is that heat is leaving you, draining into the air or the ground. You don't catch a chill, you lose a warmth, and your body notices the departure. Sound is the deep ocean's true long-distance sense, not sight. Light dies within hundreds of meters, but sound travels for kilometers through water, faster and farther than through air, because water is dense and carries vibration well. This is why the largest whales sing in deep, low tones. Those notes can cross an entire ocean basin. Where eyes are nearly useless, the deep becomes a world of listening, and a single call can reach a companion an ocean away. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. There is brine so concentrated that it forms lakes at the bottom of the sea, pooling on the seafloor with a visible shoreline 1 kilometer underwater. These brine pools are several times saltier than the ocean around them, and salt makes water heavier, so the brine sinks and refuses to mix. It lies in hollows like syrup in a dish, with waves that lap against a true edge. Fish that blunder in can be pickled by the salt. An ocean inside the ocean, kept separate by nothing but its own weight. Blow across the top of an empty bottle and it answers with a note, and adding water raises the pitch. The bottle is an air spring. Your breath sets the column of air inside it vibrating, and that column has a favorite frequency set by its length. A tall column of air vibrates slowly, giving a low note. Pour in water and you shorten the air column above it. A shorter column vibrates faster and the pitch climbs. Every flute, organ pipe, and bottle works this way. Change the length of the air, change the song. The soul takes nothing with her to the next world but her education and her culture. Plato gives this line to Socrates in the Phaedo on the day of his death. Wealth and status stay behind. Only what you have made of your mind goes on. Whether or not you read it literally, the point lands. Of everything we gather in a life, what we truly keep is what we became by learning. The rest is luggage. Every black hole spins, and a spinning one drags space around with it. Picture honey stirred by a spoon. The fluid near the spoon is pulled into the swirl whether it wants to or not. Near a rotating black hole, space itself is forced to rotate. Nothing can stand still there. Not even light can resist being swept along. This region, called the ergosphere, lies just outside the true point of no return. Inside it, you could still escape, but only by moving with the spin. The hole does not merely hold space, it winds it, like thread on a turning spindle. Magnetism is electricity seen from a different seat. Inside a magnet, countless electrons spin and circle, and each tiny orbiting charge is a microscopic current that makes its own magnetic field. In most materials, these point every which way and cancel. In iron, whole neighborhoods of atoms lock their fields into step, forming domains. Magnetize the iron and you nudge those domains to agree, and their fields add up into one you can feel. There is no separate magnetic substance, only charges in motion agreeing on a direction. After a big earthquake, the ground keeps trembling for days, and that's not bad luck. The main rupture rearranges stress all along the fault and its neighbors, loading some nearby patches past their breaking point. Those patches let go in turn, producing aftershocks that cluster in space and fade in number over time in a remarkably regular pattern. The largest aftershock tends to run about a magnitude smaller than the main shock. They aren't random echoes. They're the crust settling into a new balance after the first great adjustment. Sweat that drips off your chin does nothing to cool you. Cooling happens only when sweat evaporates, lifting away as vapor and stealing heat as it goes. This is why a humid day feels so much worse than a dry one at the same temperature. When the air is already thick with moisture, your sweat can't evaporate, so it just sits on your skin, useless. In a dry desert, the same heat is more bearable because every drop vanishes quickly and carries your warmth with it into the air. The strongest hint of life might be a combination that shouldn't coexist. Oxygen and methane react with each other. Left alone, they would quickly cancel out. Yet Earth's air holds both at once. Something must be making each faster than chemistry destroys it. And on our world, that something is biology. So scientists hunt not for a single gas, but for pairs in stubborn disequilibrium, molecules caught in a fight that no dead planet could sustain. The fingerprint of life may be a chemistry permanently, impossibly out of balance. Spices were worth their weight in part because of where they grew. Nutmeg and cloves came from a scattering of small tropical islands, and almost nowhere else, while the buyers lived oceans away. Every hand the spice passed through added a price, so by journey's end, the cost had multiplied many times over. The value wasn't in the flavor alone, it was in the sheer distance and the number of middlemen between the tree and the table. Rarity plus reach made these dried buds a fortune. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. Where two plates meet, sometimes one slides beneath the other and vanishes into the planet's interior. This is subduction, and it is how the Earth recycles its surface. The diving slab is old, cold ocean floor, dense enough to sink back into the mantle, dragging the rest of the plate behind it. As it descends, water trapped in the rock cooks out, lowers the melting point of the mantle above, and feeds volcanoes at the surface. So a chain of fire mountains marks the line where an ocean is quietly being swallowed, kilometer by kilometer, back into the depths it came from. Seneca caught how we postpone the one thing we can't afford to. We squander our days, he warned, as if drawing from a full purse, while all the time death stands at our side. The flaw is not scarcity, but the belief that there is always more. We guard our money and waste the only currency that never returns. Out here, with no future to defer to, the present is suddenly all there is. The calcium in your bones and the iron in your blood were cooked inside stars that died before the sun was born. Lighter elements like carbon and oxygen form in the fusion furnaces of aging stars. Heavier ones are scattered when those stars explode, seeding clouds of gas with fresh ingredients. From such enriched clouds, new stars and planets form. You are, quite literally, assembled from the ash of earlier stellar deaths, a fact that links your body to events billions of years gone. During exercise, your muscles need far more oxygen, yet your heart and lungs aren't told directly. The muscles announce themselves chemically. As they burn fuel, they release carbon dioxide and acids into the blood, and your brainstem reads these as a demand signal. It answers by deepening your breath and quickening your heart, scaling the supply to the mess being made. So your hard breathing isn't really triggered by the running. It's triggered by the exhaust, your body matching delivery to the waste your effort leaves behind. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. When you know a thing, hold that you know it. When you do not, allow that you do not know. Confucius in the Analects makes honesty the floor of all learning. The dark between galaxies asks the same of us. To call the unknown by its true name and not pretend. Raindrops are not shaped like teardrops at all. A small drop is a tiny sphere, pulled round by surface tension, trying to shrink its skin to the smallest area. As it falls and grows, air pressure pushes up on its underside and flattens it. So a large raindrop looks more like a hamburger bun or a tiny parachute. Grow too big and the airflow tears it apart into smaller drops. The pointed teardrop we draw exists only as water leaves a tap. Falling rain wears a rounder face. This is the story of a man who fell forever.
And oh, what a performance, what a show. A standing ovation.
Spiral galaxies are running out of time, slowly. A spiral shines blue because it still has gas to make new stars. And the hottest, bluest stars burn out fast and must be constantly replaced. When the gas is used up or stripped away, no new blue stars form, the old ones fade, and the whole galaxy reddens. So color is a clock. A blue spiral is a galaxy still giving birth. A deep red galaxy is one that has spent its supply and settled into a long, quiet old age.
With their own lives instead.
Fall toward a small black hole feet first, and gravity pulls your feet far harder than your head. The difference stretches you lengthwise while squeezing your sides. A process scientists named, half grimly, spaghettification. It happens because gravity weakens with distance, and near a compact hole that change is brutally steep across even a human body. Around a supermassive hole, the stretch is gentle at the edge. Around a small one, it tears matter apart long before the horizon. The same falling, two-faced, decided by how sharply the pull shifts from your toes to your crown. At the center of a hurricane sits a patch of calm called the eye, often bright with sunlight while ruin spins around it. Air spirals inward and rushes upward in the violent wall of cloud. But at the very core, some of that air sinks back down instead. Sinking air warms and dries, dissolving clouds and stilling the wind. So the storm's quietest place is wrapped inside its most furious one. And the calm is a trap, with the far wall and its howling wind still to come. The moon can rise looking swollen and amber, yet a ruler proves it has not grown. Near the horizon, its light passes through a long wedge of atmosphere that scatters away blue and leaves the reddened remainder, the same path that reddens a sunset. The swollen size is an illusion of your brain comparing the moon to trees and rooftops. Measure it against your thumb, low and high, and it stays identical. Only the color truly changed, and the air did that.
The song I don't sing, they were busy with their
The Tao that can be trodden is not the enduring and unchanging Tao. The Tao Te Ching begins. The name that can be named is not the enduring and unchanging name. Lao Tzu opens by admitting words fall short. The cosmos answers in kind. Vast and wordless, naming itself in nothing but light. Lightning can strike the ground some distance from where you stand and still reach you, through your feet. When the bolt hits the soil, current spreads outward and the ground itself develops a voltage that falls off with distance. If your feet are apart, one stands at a higher voltage than the other, and that difference can drive current up one leg and down the other. This is why animals in open fields are vulnerable. Their long bodies span a wide gap, and why keeping your feet close together lowers the danger. Most of the atoms in your body were forged inside stars and scattered by their deaths into clouds like the ones we drift past. Carbon, oxygen, iron, none of them existed when the universe began. They were cooked in stellar cores, then flung outward when those stars exploded or shed their outer layers. That enriched gas seeded new clouds, which collapsed into new stars and planets. You are made of recycled star, processed through generations. Every nebula is both a graveyard and a nursery, and the line between them is matter passing through. Most of the helium and carbon you encounter began inside stars through a process of patient assembly. In stellar cores, hydrogen nuclei fuse into helium, and in older stars, 3 helium nuclei collide to form carbon. This stepwise building of heavier elements from lighter ones is how the cosmos grew chemically rich. The earliest universe held almost nothing but hydrogen and helium. Everything more complex, including the carbon in every living thing, was manufactured by generations of stars. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the sea. The 32 points of the compass rose were born from wind, not magnetism. Long before the magnetic needle reached Europe, Mediterranean sailors named directions after the winds that blew from them. 8 main winds spaced around the horizon. Halve the gaps, then halve again, and you reach 32 name points, each a familiar bearing. When the magnetic compass arrived, it simply adopted this existing ring of names. So the elegant rose on old charts is really a memory of how the air moved, frozen into the language of direction. Pick up a lone boulder resting on an open plain, and you may be holding a passenger. Geologists call these erratics because they belong somewhere else. A glacier plucked the rock from a distant mountain, carried it frozen in the ice for tens of kilometers, then melted and set it down on bedrock of a completely different kind. The clue is the mismatch. Granite resting on limestone, a stone with no nearby source. Each erratic is a dropped luggage tag from a vanished ice sheet, marking exactly how far the ice once reached. Most of the great deserts hug 2 invisible belts near 30 degrees north and 30 degrees south. The reason is a loop in the air itself. Heat at the equator lifts moist air high, wrings the water out as tropical rain, then sends the dried out air toward the poles. Around 30 degrees, it sinks back down. Sinking air warms and grows thirstier, so clouds dissolve instead of forming. The Sahara, the Arabian, the Kalahari, the Australian outback all line up along this descending edge. They are not scattered by accident. They mark. Slowing pulsars reveal that these dead stars are gently bleeding away their spin. The cause is their magnetic field. As a neutron star whirls, its tilted field acts like a generator, radiating energy into space and pouring out a wind of particles. That outflow saps the star's rotation, so it turns a little slower each year. By measuring how fast a pulsar is decelerating, astronomers can estimate its age and the staggering strength of the magnetism dragging on it. A pigeon released far from home, in a place it has never been, can still set off in roughly the right direction. One ingredient appears to be smell. Winds carry distinctive blends of odors across a landscape, and a young pigeon learns which scents ride in on which winds near its loft. Taken somewhere strange, it samples the air, recognizes a familiar odor signature, and infers which way home must lie. Block its sense of smell and that long-range homing falters. Evidence the bird reads the sky partly as a map of sense. Soda lakes are among the harshest waters on Earth, with a pH closer to ammonia than to anything you would drink. They form where rivers carry dissolved sodium and carbonate into a basin with no outlet, and relentless evaporation concentrates them into a caustic, alkaline brine. Most life recoils, yet these lakes can blaze with color and teem with specialists. Cyanobacteria bloom in the soda, flamingos wade in to filter them out, and the bird's pink feathers come from pigments in that very food. A poison to most becomes a banquet for the few. The same earthquake can be deadly in one country and survivable in another, and engineering is the difference. Seismic waves don't kill people directly. Collapsing structures do. Buildings designed to flex, with reinforced frames and foundations that ride the shaking rather than fight it, can survive a jolt that flattens rigid, brittle construction next door. This is why two places struck by equal shaking can suffer utterly unequal losses. The fault sets the motion, but what we build on top decides how much of that motion becomes catastrophe. In near total darkness, color drains away and the world turns gray. Two kinds of light sensors line the retina. Cones, which read color but need bright light, and rods, far more sensitive but colorblind. As dusk falls, the cones fall silent and the rods take over, so a red flower and green leaves dim to the same shade. You are not imagining the loss. You have switched to a second visual system, one built for faint light that trades every color for the gift of seeing it all. Some of the best preserved ancient people were never buried by anyone. They sank into peat bogs and the bog did the rest. Acidic, cold, and starved of oxygen, the waterlogged moss halts the bacteria of decay and even tans skin like leather. The same chemistry that preserves the flesh dissolves the bones, so a bog body can keep its face, its hair, and the last meal in its stomach while its skeleton softens away. The marsh becomes a slow embalmer, holding a single person's final hours across thousands of years. The moon's glow reaches you about 1 1/4 seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Send a probe falling into a black hole, and from a safe distance, it never seems to arrive. Its light stretches and dims as it nears the horizon, and the image slows, reddens, and finally fades, appearing frozen just shy of the edge for all time. From the probe's own view, the crossing is quick and uneventful. It sweeps past the boundary in moments. Both pictures are correct. Gravity stretches the light's wavelength and stalls the signal so severely that the distant observer's clock and the falling probe's clock can no longer agree on a simple question: when did it fall in? Your sharpest hour and your sleepiest hour are written into your blood. Body temperature, alertness, and reaction speed all rise and fall on a daily curve set by the inner clock. Most people hit a low in the small hours and a second dip in the early afternoon, when the clock briefly relaxes its push for wakefulness. That midday slump is not weakness or a heavy lunch. It is the rhythm itself, a built-in trough that arrives whether you have eaten or not. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited. An ocean can be born, grow wide, and then die, all driven by plate motion. It begins when a continent stretches and tears, letting a rift flood with seawater. New seafloor spreads from a central ridge, and the ocean widens for tens of millions of years. But eventually the edges grow cold and dense, and the seafloor starts diving back into the mantle along trenches. Once that subduction outpaces the spreading, the ocean shrinks, the continents close in, and it shuts like a book. Whole oceans have opened and closed this way more than once. Epicurus drew a simple map of desires. Some are natural and necessary, like food and shelter. Some natural but not necessary, and some neither. Empty cravings that no amount of feeding ever fills. Sort them honestly, he taught, and most of your anxiety dissolves. The drifter needs almost nothing. Light, silence, the next slow turn, and finds in that short list an unexpected peace. The great Tao is very level and easy, the Tao Te Ching says, but people love the byways. Lao Tzu notes how we complicate the simple. Light never does. Between any 2 points, it takes the quickest path time allows, and so it crosses the whole universe by the plainest road there is. Most of the wood that ever grew has already been unmade by fungi. A fallen trunk looks solid, but threads finer than hair are weaving through it, releasing enzymes that crack open lignin, the tough glue that lets trees stand. Almost nothing else on Earth can fully break lignin down. Certain fungi are nearly alone in the trick. Without them, dead forests would pile up uncomposted, locking carbon and nutrients away. Decay is not the end of the forest, it is the forest recycled into the next one. Distant galaxies appear redder than they should, and the redness is a speedometer for the cosmos. As space stretches, it stretches the light crossing it, sliding colors toward the red end of the spectrum. The farther a galaxy lies, the more its light is shifted. By reading that color slide, astronomers measure how fast the universe pulls itself apart at every distance. A swinging weight keeps near perfect time, and that quiet fact transformed the clock. For modest swings, a pendulum of a given length takes about the same time to travel back and forth, whether the arc is a little wider or a little narrower. That steadiness is the heartbeat a good clock needs. Couple a pendulum to a gear that releases 1 tooth per swing, and you can count time mechanically, far more reliably than dripping water or falling sand. The discovery that swing length, not swing size, sets the rhythm is why a tall clock ticks evenly, and why be still as a mountain, move like a great river. This old Taoist saying joins two opposites in one body. The stillness gives the motion its meaning. A traveler tumbling through the void carries both, calm at the core while the whole cosmos streams silently past. Type Ia supernovae explode with such consistent brightness that astronomers use them as cosmic measuring sticks. The reason lies in their trigger. Each begins as a white dwarf that pulls matter from a companion until it nears that universal mass ceiling. Reaching the same critical point, the stars detonate with nearly the same energy every time. Because we know their true brightness, comparing it to how faint they appear reveals their distance, letting us map the scale of the universe. When you know a thing, to hold that you know it, and when you do not know a thing, to allow that you do not know it, this is knowledge. So Confucius defines it in the Analects. Real wisdom begins by mapping the edge of one's ignorance. The night sky teaches the same humility. The more we learn of it, the wider its dark margins grow. A shark can find a fish buried in sand, in total darkness, by feeling its heartbeat. Scattered across the shark's snout are tiny jelly-filled pores called the ampullae of Lorenzini. Every beating heart and twitching muscle leaks a faint electric field into seawater, and that jelly conducts it down to sensory cells. The shark reads voltages smaller than a millionth of a volt, fine enough to detect the spark of life in something it cannot see. In the final lunge, when its eyes roll back for protection, electricity guides the bite. The cosmos is not expanding into anything, and there is no center to find. Imagine dots drawn on a balloon as it inflates. Every dot drifts from every other, yet none sits at the middle, and the surface has no edge. Galaxies spread the same way. Each one sees all the others receding, because the space between them all is growing at once, with no special place and no outside. Marcus Aurelius watched the world the way you might watch a fire. Observe always that everything is the result of change, he wrote, and get used to thinking there is nothing nature loves so well as to change existing forms and make new ones like them. Decay troubled him less once he saw it as nature's favorite move, not an accident. Stars do exactly this, dying into the matter of stars to come. Somewhere behind him, a world he can no longer name. The taste of your tongue is rebuilt on a schedule. Each taste bud holds a cluster of sensing cells, and those cells are surprisingly short-lived, many lasting only a week or two before they die and are replaced. New cells arise from a reserve pool at the base of the bud and mature into working sensors. This is why a scald from hot coffee dulls taste for only a few days. The burned cells are simply swapped out and flavor returns. Your sense of taste is not a fixed instrument. It is a population of cells in constant turnover. the whole tasting apparatus quietly renewing itself again and again. If you fell into a large black hole, you would not see a wall rushing toward you. The event horizon is not a place your eyes could find. You could drift across it and notice nothing unusual in that instant. Space looks ordinary. You feel weightless, still falling. The horizon is defined only by what happens after. From there, no signal you send can ever climb back out. The boundary is real but invisible, marked not by anything present, but by a future that is quietly closed. You cross the most decisive line in physics without seeing it pass. In limestone country, a river can simply vanish. The water reaches a spot where the rock below has been dissolved into open channels, and the entire stream pours down a hole in its own bed, called a sinkhole or swallow hole. It travels underground for a stretch, then rises again somewhere downstream as if nothing happened. The dry channel left behind only floods when the underground route can't swallow it all. A disappearing river hasn't ended. It has gone subterranean. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Two musicians tuning slightly out of step produce a slow throb, a wobble in the loudness that neither note contains alone. It's called a beat, and it comes from waves adding and canceling. When two pitches are almost identical, their peaks drift in and out of step. Where peaks line up, the sound swells. Where peak meets trough, they cancel and it dims. The throbbing rate equals the exact difference between the two frequencies. Tuners listen for it. As the notes converge, the beats slow, and when they vanish entirely, the two are perfectly matched. Whatever the dark matter is, it must be slow. If it moved near light speed in the early universe, it would have streamed out of small clumps and erased them, leaving only giant structures. But we see small galaxies everywhere, so the leading picture calls it cold, sluggish, heavy particles that gather gently and let small things form. The temperature of the unseen, inferred purely from the sizes of the structures it built, is one of the few things we can say about it. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the rocks along a locked fault don't slide smoothly, they snap. For years, the two sides press past each other while friction holds the seam in place. So the rock bends and stores elastic energy like a drawn bow. When the stress finally beats the friction, the fault lurches in seconds and the stored strain springs free as seismic waves. That sudden release is the earthquake. The slow part takes decades. The violent part is over before you can stand up. The ground you feel shaking is rock unbending, returning to a shape it was forced to abandon. fast mountain river suddenly meets a flat valley, it dumps a fan of debris shaped like an open hand. Confined in its canyon, the water moves fast and carries gravel and boulders. The instant the valley opens, the flow spreads thin, slows, and drops its load at the canyon mouth. The channel chokes on its own gravel, splits, and shifts sideways, spreading deposits in a broad cone called an alluvial fan. It is a delta built not into water, but onto dry land. Run today's acceleration far into the future, and galaxies beyond our own gravitationally bound group will drift away faster and faster, their light stretched until it fades from view. An observer in that distant era, seeing only nearby stars, might conclude the universe is small, static, and alone, with no hint of the vast cosmos that once filled the sky. The same expansion that we measure now is quietly erasing the evidence. We may live in a privileged moment for reading the universe's past. Every night you are briefly paralyzed, and it keeps you safe. During dreaming sleep, the brainstem actively shuts off the spinal motor signals that move your limbs. Your eyes still flick, your breathing continues, but the body is held still. The reason is protective. In vivid dreams, the motor cortex issues real commands: run, reach, flee. And without the block, you would act them out and risk hurting yourself. People in whom this switch fails do exactly that, kicking and lunging at dreams. The stillness of a sleeping body can... For its first few 100,000 years, the universe was opaque, a fog you could not see through. It was so hot that electrons roam free, and free electrons scatter light endlessly like headlights in dense mist. Only when it cooled did electrons bind to nuclei and the fog lift. The light released in that moment still travels today, the boundary beyond which no telescope can ever look. Time is a child playing drafts. The kingly power is a child's. Heraclitus pictured the universe's ruling principle as a child idly moving game pieces, order arising from something like play. The cosmos has that careless air. No hand arranges the constellations into meaning. Positions simply shift by physical law, and the grand patterns we read into them are moves in a game with no player in mind. Epictetus drew a clean border around what is actually ours. Some things are in our power, he taught, and some are not. Our judgments and desires are ours, while our bodies, fortune, and fame are not. Peace begins the moment you stop defending the territory you never held. The fallout there is in the second column, outside any grip. What remains in the first is how it is met. Light from a far cosmic explosion arrives stretched and delayed compared to a closer one, and that difference reveals expansion. Light from a nearby blast comes through quickly. Light from a distant one is lengthened by the growing space it crosses. By comparing how stretched the light is against how distant the source must be, astronomers chart how the cosmos has expanded across its long history. At the very top of every Roman arch sits one block doing a quiet, crucial job, the keystone. Until it drops into place, an arch is not an arch. It is two leaning half curves that would collapse without a wooden frame holding them up. The final wedge, hammered into the gap at the crown, locks the two sides against each other. Now each stone pushes on its neighbor all the way around, and the temporary timber frame can be pulled away. The arch suddenly stands on its own. One stone converts a pile of blocks into a bridge. Press your thumb into wet clay and it remembers the shape. 5,000 years ago in Mesopotamia, scribes did exactly that, pushing a cut reed into clay tablets to make wedge-shaped marks. We call it cuneiform, from the Latin for wedge. Clay was everywhere along the rivers, and once it dried in the sun, it held its marks for millennia. That durability is why we can still read their grain receipts and tax lists today. Writing did not begin with poetry or prayer. It began with accounting, with someone needing to remember exactly how much barley was owed. He who fights with monsters should look to it that he himself does not become a monster. And when you gaze long into an abyss, the abyss also gazes into you. Some forests make their own weather. On a tropical mountain, mist hangs in the trees almost every day, and the reason is altitude meeting moisture. Warm air rises off the lowlands, carrying water vapor, and as it climbs the slope, it cools. Cooler air holds less water, so the vapor condenses into a near-permanent band of cloud that wraps the ridge. The trees comb droplets straight from this fog, and the water drips to the soil. Whole streams begin not as rain, but as forest combing water out of passing cloud. Two rivers can run side by side in one channel without blending, each keeping its own color. It happens where a clear, dark river meets a pale, sediment-laden one. They differ in temperature, speed, and density, and those differences resist mixing. So the two waters flow together for miles with a visible seam between them, dark on one side, sandy on the other. Only slowly does turbulence stitch them into one. A river's color marks where its water has been, and water remembers. Some dead stars sweep a beam across space like a lighthouse, and we call them pulsars. The mechanism is rotation. When a massive star collapses, it spins faster, the way a skater pulls in their arms, until the remnant can turn dozens of times a second. Its powerful magnetic field channels radiation into two narrow beams from the magnetic poles. If one beam happens to sweep past us, we see a pulse, then darkness, then a pulse again, ticking with a regularity that rivals an atomic clock. You cannot tickle yourself, and the reason hides in prediction. Before you move a hand, the cerebellum sends a copy of the command forward and forecasts exactly what your skin will feel. When the touch arrives on schedule, the brain dampens it, labeling it self-made, unimportant. Tickling depends on surprise, on a touch your forecasting cannot cancel. Your own fingers are too predictable to startle you. Add a machine that delays the touch by a fraction of a second. Breaking the forecast and self-tickling can suddenly begin to work. Even empty space is not truly empty. Quantum theory says the vacuum sees with fleeting energy as particles flicker in and out of existence. That restless energy should gravitate. It should bend space and affect how the cosmos expands. But when physicists calculate how much energy the vacuum holds and compare it to what the universe actually shows, the two numbers disagree by a margin so vast it defies casual description. This mismatch between quantum prediction and gravitational reality is among the starkest unsolved problems in physics. A few deserts get most of their water without a single drop of rain. Along certain cold current coasts, thick fog rolls inland off the sea day after day. Specialized plants and lichens comb moisture straight from that mist, and people string up fine mesh nets that do the same, dripping captured fog into tanks below. The sky here almost never opens, yet the air is heavy with water. Where rain has given up, fog quietly keeps a whole community alive, one beat at a time. Where an aqueduct met a deep valley too wide to bridge, the Romans played a trick with pressure. They sent the water down one slope inside sealed pipes, across the bottom and up the far side, an inverted siphon. Water seeks its own level, so as long as the far side sat lower than the start, the flow would climb the opposite hill on its own, pushed by the weight of the water behind it. No pump, no power, just the stubborn physics of liquid in a closed tube. It let a channel cross a gorge without a towering bridge of arches. Who can make the muddy water clear? Asked the Tao Te Ching. Let it be still, and it will gradually become clear. Lao Tzu trusts stillness to do the work that stirring cannot. A settling mind clears the same way a glass of clouded water does, not by force, but by being left alone. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. Lock two plates together at their edge, and the boundary itself can creak in a straight line for hundreds of kilometers. Along such a fault, two plates grind sideways past each other, but rough rock snags and holds, so the land on either side bends and stores a strain like a loaded spring. The slip does not happen smoothly. It waits, building tension over decades, then lets go all at once in a sudden lurch. That lurch is an earthquake. The fault clusters its shaking precisely along the line where the two plates meet and resist. The Himalaya are still growing, a few millimeters a year, because India is driving north into Asia, like a slow battering ram. Once these were two separate land masses with an ocean between them. The seafloor sank away, the continents collided, and neither would slide under the other, so the crust had nowhere to go but up. That crumpling is what stacks rock into the highest peaks on Earth. Press two rugs together on a smooth floor, and the cloth bunches into ridges. The planet does the same thing, only in granite. Approach a black hole, and the sky behind it warps into a ring. Light from the stars directly beyond the hole cannot pass through, so it bends around the edge instead, curving along the steep slope of space. Rays that would have missed you are steered into your eye, and the hole becomes a lens, smearing the background into bright arcs. You can even see the same star twice, its light routed around opposite sides. Gravity does not block the view. It rearranges it, painting a halo of bent starlight around a circle of absolute black. We suffer more often in imagination than in reality, Seneca wrote to a friend. The fall has no bottom rushing up, no jaws below, only the mind supplying both. Strip away what is merely pictured, and what remains is quieter than you feared. Motion, distance, and stars that do not care. War is the father of all and the king of all. Heraclitus did not mean armies. He meant tension. Opposed forces that, by pulling against each other, hold a thing in being. Slacken the strife and the thing dissolves. A planet is exactly this truce. Gravity pulling inward, hot pressure pushing out. The sphere existing only in the standoff between them. Perfect peace for a world would be collapse. If you are watching, you are falling with him. The first elements heavier than hydrogen were not made in stars at all, but in the opening minutes of the universe. In that brief, searingly hot window, the entire cosmos acted as a fusion reactor, binding protons and neutrons into helium and a trace of lithium. Then it cooled, and expansion quenched the reactions before anything heavier could form. Every atom beyond lithium had to wait for the first stars to live, die, and seed space with their richer ash. How do you even count the living? The usual unit is the species, defined by who can breed with whom. But for the microbes that make up most life on Earth, that test fails completely. They reproduce by copying themselves alone, and they swap genes sideways with unrelated neighbors, blurring any family tree. So the tidy idea of a species drawn from animals and plants dissolves at the scale where life is most abundant. The way we organize the living world turns out to fit only the small, late branch we belong to. The shaking from a quake is not the same in every direction. A rupture doesn't happen all at once. It tears along the fault like a zipper, often at a few kilometers per second. Where the tear runs toward you, the waves it makes pile up ahead of it, stacking into a stronger, sharper pulse, much as a siren sounds higher as it approaches. This directivity means towns in the path of the rupture can be hammered harder than towns the same distance away, sitting behind where the tear began. Some stars you admire tonight may no longer exist. Light from a distant sun can take thousands of years to cross the gap to Earth. If such a star burned out a millennium ago, its final light is still in transit, still painting a point on your sky. You would go on seeing it shine faithfully until that last wave of light swept past. The star is gone, but its image lingers, a candle whose flame we still watch long after the wick is cold. Egyptian blue may be the oldest synthetic pigment ever made, baked from sand, lime, and a copper mineral over 4,000 years ago. Here is the quiet marvel. Shine red light on it, and it glows back in the near infrared, invisible to our eyes but bright to a camera. That happens because copper atoms locked in its crystal absorb visible light and re-emit it at a longer wavelength. Conservators now hunt for traces of it on faded statues by photographing that infrared glow, reading a color the ancients mixed 2 miles beneath the surface, in rock with no sunlight and no oxygen, living cells are quietly feeding. Their energy doesn't come from the sun at all. Radioactive atoms in the rock split nearby water molecules, freeing hydrogen, and the microbes burn that hydrogen for power. It's an entire food web running on the slow decay of the planet itself. The point that lingers as you pass over: sunlight is not a requirement for life. It is simply the energy source most familiar to us, and underground, life found another. Some black holes fire jets of matter across distances larger than the galaxies that host them. Gas spiraling inward gets caught in twisted magnetic fields near the spinning hole, and instead of falling, part of it is flung outward along the spin axis at nearly light speed. These beams can stretch for thousands of light years, lighting up in radio waves. It is a paradox in plain sight. The most efficient trap in the universe is also one of its great launchers. What the whole cannot swallow, it hurls back into the dark with astonishing force. A clock moving fast through space genuinely ticks slower, and we have caught it doing so. Fly an atomic clock around the world, and it returns a tiny fraction of a second behind its twin left at home. The faster you travel, the more time dilates. It sounds like fantasy, yet satellites must correct for it constantly. Their onboard clocks, racing in orbit, drift from clocks on the ground. Time is not a fixed background. It bends with speed, and the universe keeps the books precisely. Babies can borrow immunity they never earn. During pregnancy, antibodies cross from the mother's blood through the placenta into the fetus, and more arrive later through breast milk. For the first months of life, a newborn is partly defended by memory of diseases the mother met, but the baby never has. This borrowed shield fades as the infant's own immune system matures. For a while, two immune histories overlap in one small body. The protection of one generation quietly covering the start of the next. Nearly every atom of gold in existence was forged in catastrophe. Stars fuse hydrogen into helium, then heavier elements, but the building stalls at iron, because fusing iron drains energy instead of releasing it. So how do we get gold, platinum, uranium? In the violence of collapsing stars and colliding neutron stars, free neutrons flood in faster than atoms can decay, building heavier and heavier nuclei. The ring on a finger carries metal assembled in some of the most extreme events the cosmos allows. The moon's glow reaches you about 1 1/4 seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Galaxies did not have time to form from ordinary matter alone. In the early universe, atoms were locked in a glowing fog with radiation, unable to clump. Only when that fog cleared could atoms begin to gather, and that is late. Yet galaxies exist, full and grand. The fix: a kind of matter that ignores radiation and starts collapsing earlier, building gravitational wells that ordinary gas later falls into. Without that head start, the universe would still be a smooth, starless haze. The first ecosystems found around deep-sea vents overturned a rule biology thought was unbreakable. that all life ultimately runs on sunlight. Here, bacteria draw energy from chemicals in the vent water instead, a process called chemosynthesis. They build living tissue from hydrogen sulfide that would poison most creatures. Everything else at the vent eats those bacteria. An entire food web stands on chemistry, not on light, proving life can run on the planet's own heat and stone alone. Marcus Aurelius reduced the whole universe to 2 words. The universe is transformation, he wrote. Life is opinion. Nothing in the cosmos stays as it is. All of it is mid-change. And the way we feel about that change is something we add ourselves, a judgment laid over a neutral fact. The drift out there is only motion. Whether it reads as loss or as wonder is opinion, and opinion is the one thing we hold. There is a hard ceiling on how heavy a white dwarf can be, roughly 1 4/10 times the mass of the sun. Push past it, and the star cannot survive. White dwarfs are held up by the pressure of densely packed electrons, but that support has a limit. Add too much mass, and the electrons are forced to move near light speed, where they can resist no further. Gravity wins, and the star either collapses or detonates as a brilliant, oddly uniform kind of supernova. Quakes can talk to each other across the planet. As seismic waves from a great rupture sweep through distant regions, they momentarily stress faults far away, and a fault already near its breaking point can be nudged into slipping. This dynamic triggering means a major event in one place can spark small tremors thousands of kilometers off in the brief minutes the waves pass through. The faults were already loaded and waiting. The passing waves were simply the final touch that tipped them over the edge. A stalactite grows from the ceiling 1 drop at a time. Water seeping through limestone arrives loaded with dissolved calcium carbonate. As each drop hangs from the rock, a little carbon dioxide escapes into the cave air, and the water can no longer hold all its mineral. A microscopic ring of calcite is left behind. The next drop adds another ring and another, until a stone icicle reaches downward. It can take a century to grow the width of a finger. The stalactite is, in truth, a tower built of abandoned water. The cosmic background glow has a temperature, and you can read the universe's history in it. Today, that ancient light sits at just under 3 degrees above absolute zero. Long ago, it was far hotter, because the same expansion that cools it now once kept it compressed and blazing. Measure its temperature at different cosmic eras, and you trace exactly how much the universe has stretched. In a cave in Mexico, crystals grew longer than a person is tall, some of them many meters long. The Cave of the Crystals holds these beams of gypsum because of stillness and steady heat. Magma far below kept the groundwater at a warm, almost unchanging temperature for hundreds of thousands of years, held just below the point where gypsum, rather than its drier cousin, is the form that stays solid. With no disturbance and endless time, a few crystals grew and grew instead of many growing small. Patience made solid. Deep in a glacier, the air of the ancient sky is held prisoner. As snow falls year after year, it traps tiny bubbles before it crushes into ice. Drill a core a kilometer down, and you pull up a column where each layer is a sealed sample of old atmosphere. Crack the bubbles in a lab, and you measure the carbon dioxide of a world that vanished long ago. The ice keeps these layers in order, oldest at the bottom, so the climate of hundreds of thousands of years can be read straight off a frozen ladder. Freezing rarely kills directly through cold. It kills through sharp ice crystals that tear cell membranes apart from inside. This is why some animals do the opposite of freeze-tolerant ones. They refuse to freeze at all. By purging every speck of dust and bacteria that ice could form around and thickening their fluids, they can chill their bodies far below the normal freezing point while staying liquid. The water is poised, desperate to crystallize with nothing to start it. This trembling stillness is called supercooling, and on it rests the winter survival of countless small lives. Every black hole spins, and a spinning one drags space around with it. Picture honey stirred by a spoon. The fluid near the spoon is pulled into the swirl whether it wants to or not. Near a rotating black hole, space itself is forced to rotate. Nothing can stand still there. Not even light can resist being swept along. This region, called the ergosphere, lies just outside the true point of no return. Inside it, you could still escape, but only by moving with the spin. The hole does not merely hold space, it winds it like thread on a turning spindle. An organ's deepest pipes are longer than a person is tall, and the length is no accident. A pipe makes its note by setting a column of air vibrating, and the longest waves need the longest columns to fit. The lowest notes the ear can hear stretch many meters from peak to peak, so the pipe must be sized to match, sometimes 10 meters or more. Halve a pipe's length and its pitch jumps an octave. The towering pipes you see are not for show. They are the physical size of the lowest sounds built in wood and metal. The whole sky's worth of weather lives in a layer thinner than you'd guess. Most of the air is pressed into the lowest 10 kilometers or so, a thin shell wrapped around a planet whose radius runs to more than 6,000 kilometers. We call that bottom layer the troposphere, and nearly every cloud, storm, and gust happens inside it. Above, the air thins toward nothing. The breathable skin that holds all our weather is, in proportion, no thicker than the dew on an apple. Some of the most famous towering rock walls were never pushed up as mountains. Instead, a slab of especially hard rock simply refused to erode, while softer rock all around it washed away. As rivers and weather lowered the surrounding land for millions of years, the stubborn block was left standing alone, a sheer monolith rising from a flat plain. It did not grow taller. The world around it grew lower, and what remains is the toughest leftover of a landscape that has otherwise vanished. Move a giant stone block across a rough ground with no wheels strong enough to bear it. How? One old answer is the roller. Lay logs under the load, push, and as the block rolls forward off the back logs, you carry them around to the front and feed them in again. An endless conveyor of timber. Rolling friction is far smaller than sliding friction, so a few dozen people could inch a monster forward. The block never stopped riding on fresh logs. Slow, rhythmic, and tireless, it moved weights that should have been immovable. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world. And wait, some bacteria in your gut actively defend their turf with chemistry. They produce small toxins called bacteriocins, narrowly aimed at rival strains competing for the same space and food. To you, it's invisible, a microscopic war fought in your intestine to decide who lives there. But the outcome matters. When friendly residents win these battles, they keep the population stable and leave fewer openings for harmful invaders. The peace in your gut is not calm. It's a balance held by countless small skirmishes you never feel. A supernova can briefly release more energy than the sun will emit across its entire 10 billion year lifetime. The source is gravitational collapse. When a massive core falls inward, an immense store of gravitational energy is suddenly liberated, most of it carried away by neutrinos in seconds. Only a small fraction becomes visible light, yet even that sliver can outshine a whole galaxy. For a few weeks, a single exploding star can be seen across vast stretches of the universe. When you nick your finger, the first responders aren't whole cells at all, but tiny fragments. Platelets are broken off pieces of much larger cells in your marrow, with no nucleus and no full life of their own. They drift through your blood by the billions, doing nothing, until they touch the torn edge of a vessel. Contact with exposed tissue makes them sticky and changes their shape, sprouting tendrils that grab one another. In seconds, they pile into a soft plug. Then they release signals that summon more. The seal that stops your bleeding begins with cell crumbs. Somewhere behind him, a world he can no longer name. Flowstone drapes some cave walls like frozen curtains of melted candle wax. It forms where mineral water doesn't drip, but sheets across the rock. As the thin film glides over the surface, carbon dioxide escapes and calcite is laid down in layer upon layer, following every bump and ledge. Over long spans, the deposits build outward into smooth, rippling folds. Slight changes in the water leave faint colored bands, like growth rings. The curtain never flowed as stone. It is the fossilized path of countless sheets of water. A triangular sail let a ship sail almost into the wind. The lateen sail, hung at an angle, works like a wing. Air flowing across its curve pulls the boat forward, even when the wind comes from ahead, not behind. Older square sails push best when running downwind, waiting for a following breeze. With this one change of shape, vessels could tack against the wind and reach harbors that were once awkward to make. Trade routes widened, not from braver crews, but from a smarter cut of cloth. Life may not have needed warmth to begin. It may have needed ice. In freezing water, growing ice crystals push dissolved molecules into shrinking pockets of liquid between them, crowding them together far more tightly than open water ever could. That crowding can drive fragile molecules to join into longer chains that would never form when dilute. So cold, usually the enemy of chemistry, might have acted as a concentrator. The reactions that started life could have been squeezed into being inside the spaces left by freezing. Beneath Yellowstone, there is no narrow vent, but a vast reservoir of partly molten rock, fed by a hot spot under a continent rather than an ocean. When a plume rises beneath thick continental crust, it cannot punch straight through. Instead, it pools and melts the overlying rock, brewing thick, silica-rich magma. That stickiness is exactly why such places, when they finally release, can do so explosively rather than gently. The same heat that warms the famous hot springs is the shallow edge of something enormous and slow, breathing on a time scale of stars far heavier than the sun and their lives by collapsing into black holes, but only the most massive ones. When such a star runs out of fuel, nothing remains to hold up its core against its own weight. Gravity wins completely, crushing the core past every known limit until not even light escapes the point it reaches. Lighter stars stop at a dense ember. Only the heavyweights fall all the way through. The same force that lit the star for ages now closes over it. A black hole is, quite literally, the corpse of a giant that could no longer hold itself up. Here is the unsettling arithmetic. Our galaxy holds hundreds of billions of stars, and many are far older than the sun, old enough that any civilization could have spread across the whole galaxy long before Earth even cooled. By that logic, the sky should be crowded. Instead, it is silent. That gap between expectation and quiet has a name: the Great Silence. It is not an answer, only a sharpened question. If the galaxy had time to fill, where is everyone? The emptiness itself is data we don't yet know how to read. The sun is new every day. Heraclitus meant it almost literally, that yesterday's fire is spent and today's freshly kindled. The fact rhymes with the science. The sunlight on any face left the sun's core as gamma rays that took ages to crawl to the surface, then about 8 minutes to cross to here. The light you meet is always newly escaped, and the source that made it has already moved on. A white dwarf the size of Earth can be hotter than the surface of the sun, yet it produces no energy at all. The heat is left over. Having ceased all fusion, a white dwarf is simply the exposed, glowing core of a dead star, cooling like an iron pulled from a forge. Because it is so small and dense, it radiates that stored warmth slowly. The faintest, coolest of these embers have been cooling for nearly the entire age of the universe and have barely gone dark. Roman numerals are wonderful for carving and terrible for arithmetic. Try multiplying 48 by 93 using only x, v, and I, and you will see the problem. There is no column for tens, no place where a symbol's position changes its worth. The number system we use instead came through Arabic mathematics from India, and its magic is place value. The same digit means 1, 10, or 100 depending on where it sits. That single idea, position-carrying meaning, is what let ordinary people calculate without an abacus. And why the old, some deep-sea fish carry a living lantern they did not build themselves. Inside special organs, they keep colonies of glowing bacteria, feeding and sheltering them in exchange for light. The fish cannot make the glow alone. The bacteria cannot easily survive alone. It's a partnership written into the body. An anglerfish dangles such a lure above its jaws, a bacterial beacon that draws curious prey straight toward the teeth. The light is a trap, and it belongs to two species at once. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-crank model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Waste no more time arguing about what a good man should be. Be one. Marcus Aurelius cut through his own delay. Out here, there is no audience to convince and no debate to win. Only the long opportunity to simply be what one keeps meaning to become. Walking someone else's crooked miles. Look deep into space and you are looking deep into the past, with no way to see the present. Light from the sun is 8 minutes old before it warms your face. Light from distant galaxies left before the Earth existed. The farther out you peer, the younger the universe you witness. There is no map of how the cosmos looks right now, only a layered fossil record written in light. Some clouds carry a map on their underside. Over a shallow lagoon, sunlight bounces off pale sand and bright water and throws a faint greenish glow onto the cloud's base, a tint a trained navigator could read from beyond the horizon. A dark underbelly hinted at forested land below. A whitish sheen suggested sand or reef. Because clouds also tend to pile and hover over warm islands, while open ocean stays clearer, that lingering cloud, stained from beneath, became a signpost. The island, still invisible, was painting its portrait on the sky. Shine white light through a cloud of cool hydrogen, and the light comes out scarred, with thin black lines missing from the rainbow. The gas has stolen specific colors. Each electron in hydrogen can only absorb light that matches the exact jump it needs to climb to a higher level. Wrong color, no jump, no absorption. Only the precise energies vanish, leaving dark gaps at fixed positions. Those gaps form a barcode unique to hydrogen. It is how we read the makeup of stars we will never visit. Their light arrives. Parmenides argued that what is, and it is impossible for it not to be. That genuine non-being cannot even be spoken of. From it, he drew a startling claim. Change is an illusion. Reality one unbroken whole. He was wrong about the changeless part, yet near the mark that emptiness resists existing. Even the deepest vacuum between stars is never truly nothing. it still hums with faint fields and stray light. Why call it dark rather than just dim? Because it is silent across the whole spectrum. Dim things still glow faintly in infrared or radio. Cold gas still absorbs passing light, leaving fingerprints. This material does neither. As far as we can tell, it does not emit, absorb, or scatter light at any wavelength we can probe. It interacts through gravity, and likely nothing else we have yet caught. That is why long searching has weighed it precisely, yet never once seen it directly. Spend time near a black hole and you return to a future. Because gravity slows time, a person orbiting close to the horizon ages more slowly than one far away. Years for them might be decades for everyone else. This is no thought experiment. The same effect, far gentler, is measured on satellites whose clocks run faster than clocks on the ground. Deepen the gravity and the gap widens without bound. Near a black hole, patience becomes a kind of time travel. Slow your own clock against the universe, and the cosmos races ahead while you barely move. Your eyes jump 3 or 4 times a second, yet you never see the blur. During each flick, called a saccade, the brain briefly switches off visual processing, a phenomenon known as saccadic suppression. You go momentarily blind, dozens of times a minute, and your world is stitched from still frames whose cuts you never notice. Try it. Watch your own eyes in a mirror as you glance left, then right. You will never catch them moving. The blindness erases its own evidence, every single time. We can study the universe's baby picture, taken before a single star was born. The oldest light comes from an era with no galaxies, no stars, only a glowing fog of hydrogen and helium. That light has crossed nearly the entire history of the cosmos to reach us. Reading its faint pattern, astronomers reconstruct what everything was made of long before the first star ever ignited. The Hawaiian Islands are a line of volcanoes laid down one after another, and they grow older as you travel northwest. The reason is strange and beautiful. The volcanoes move, but their source does not. Deep in the mantle sits a fixed plume of rising heat, a hot spot. The Pacific plate slides slowly over it, so each island is built, carried away, and goes quiet, while a fresh one forms over the same stationary wound. The chain is a conveyor belt of dead volcanoes, with the living one always at the moving end. When something distressing happens, the brain stores both the facts and the sharp feeling attached. During REM sleep, when stress chemicals fall to their lowest of the whole day, the brain replays the memory in that calmer chemical bath. Overnight, the event is remembered while its sting softens. So emotion can fade faster than the memory that holds it, and sleep is why. This is the quiet work of dreaming, keeping the lesson, dissolving the alarm, letting time and sleep take the edge off pain. Our sun will not explode. It will quietly shrink into a white dwarf, an ember the size of Earth holding nearly half the sun's mass. The reason is mass. Only stars far heavier collapse violently. When the sun exhausts its fuel, it sheds its outer layers and leaves behind its dense core. No more fusion holds it up. Instead, a quantum rule, the pressure of tightly packed electrons refusing to share the same state, props it against gravity. It will simply cool, fading over billions of years. The observable universe has a wall, and it is made of age, not distance. Light moves fast, but not infinitely fast. So we can only see objects whose light has had time to reach us since the cosmos began. Anything farther sent its light too late to arrive yet. The edge we perceive is simply the line where the universe runs out of time to show us more. Decisions can leave a trace in the brain before you feel yourself choosing. In careful experiments, patterns of activity tied to a simple choice, which hand to move, appear a fraction of a second before the person reports deciding. The conscious sense of willing seems to arrive after the machinery has begun. What this means is fiercely debated. Perhaps awareness is a narrator, reporting choices already underway rather than making them. The fact is solid. The interpretation is wide open. Few findings press harder on the feeling that you are the author of your own acts. Look at the Andes, and you are looking at the front edge of a continent being crumpled and burned at once. An ocean plate is diving beneath South America, and two things happen along that line. The collision crushes and lifts the continental rock into a high spine of mountains. Meanwhile, the sinking slab feeds volcanoes that pile fresh rock on top. So the range rises from both pressure and fire, the squeeze of two plates meeting and the melt of one plunging under. It is a mountain belt and a volcanic chain built by the very same boundary. The lining of your stomach holds back acid strong enough to break down the meat in your meal, yet it isn't burned away, and renewal is the trick. The cells facing that acid are sacrificial. They live only a few days before the acid and enzymes wear them down, so the stomach replaces its surface lining roughly every few days. Stem cells in the deeper folds churn out fresh cells that migrate up to the firing line. A thick coat of mucus buys each cell a little time, but the real defense is speed of replacement. The wall survives its own acid not by being tough, but by divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world. And a waterfall's plunge pool can be deeper than the falls are tall. The water hits the bottom with tremendous force, and that downward punch, helped by air bubbles and swirling sand, scours out the riverbed below far more aggressively than ordinary flow. The pool deepens until it reaches rock too tough to cut. So the calm, dark water at a waterfall's foot hides the most violent erosion on the whole river, drilling downward exactly where the falling water lands. Picture a galaxy not as a flat disk of stars, but as a star-flecked cloud sunk inside a vast invisible ball. That ball, the dark matter halo, reaches far beyond the visible edge, several times wider than the glowing part. The stars are a bright pebble in a dark snowball. We trace the halo's size by following stray stars and gas streams far out, still feeling its pull where no light remains. Most of a galaxy, by mass, is the part you cannot see. A heavy truck and a small car in a collision feel forces of exactly equal strength on each other. The laws of motion insist on it, yet the car suffers far more. because the same force shoves a light object much harder than a heavy one. Force divided by mass gives the change in motion, and the car's small mass means a violent jolt. The truck barely flinches. Equal pushes, unequal fates, the difference written entirely in how much matter each one carries. A passenger feels thrown outward as a car rounds a sharp bend, pressed against the door. Yet no force is actually pushing them out. Their body simply wants to keep moving in a straight line, as all moving things do. The car turns. The body resists turning. The door swings into the body's path and shoves it inward along the curve. What feels like an outward push is really the seat's inward correction, fighting your stubborn urge to fly off straight. The hidden harmony is better than the open. Heraclitus prized the order you cannot see over the order you can. Gravity is his favorite example, though he never named it. Nothing visible connects a moon to its world, yet an invisible accord governs the whole dance. Silent, constant, and far stronger than the obvious arrangement of light scattered across the sky. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Sagittarius A, the giant at our galaxy's center, is over 4 million solar masses. Yet its horizon would fit comfortably inside the orbit of Mercury. That is the strange economy of black holes. All that mass collapses into a region smaller than a single planetary path. Pack enough weight into a small enough space, and gravity seals it off behind a horizon. The bigger the mass, the wider that horizon grows, but always far tighter than the spread of stars around it. A whole galaxy turns around a dark coin no broader than the inner solar system. Two galaxies can collide and almost nothing hits anything. Galaxies are so empty that when they merge, individual stars rarely touch. The gaps between them are millions of times wider than the stars themselves. Instead, gravity does the violence. It stretches both galaxies into long tails and bridges, scrambles their orbits, and triggers bursts of star birth as gas clouds slam together. Over hundreds of millions of years, the two settle into one. A galactic crash is not a smash, but a slow gravitational reshaping of nearly empty space. In a rainbow, red rides the outside and violet the inside, and the order is set by physics, not chance. As sunlight bends entering and leaving a raindrop, each color bends by a slightly different amount. Red exits at about 42 degrees, violet at around 40. Since violet leaves at the tighter angle, it lands lower in the bow, with red stretched above. The whole spectrum is just one beam of sunlight, fanned out by the precise bending power of water. Some stars you admire tonight may no longer exist. Light from a distant sun can take thousands of years to cross the gap to Earth. If such a star burned out a millennium ago, its final light is still in transit, still painting a point on your sky. You would go on seeing it shine faithfully until that last wave of light swept past. The star is gone, but its image lingers, a candle whose flame we still watch long after the wick is cold. Goosebumps are a leftover reflex from a furrier past. When you're cold or startled, a tiny muscle at the base of each hair contracts and pulls the hair upright. In a thick-coated animal, raised fur traps a warmer layer of air or makes the body look bigger to a threat. You kept the wiring but lost most of the coat. So all that remains is the dimpling of your skin. It's a small, honest fossil, a once useful response, still firing on cue, working a fur you no longer have. Your gut microbes make vitamins you can't make yourself. Certain bacteria living in the large intestine synthesize vitamin K and several B vitamins as byproducts of their own metabolism. Some of those molecules cross into your bloodstream and enter your chemistry. It's a quiet exchange. You supply a warm, fed home, and they hand back nutrients your own genome never learned to build. The figure drifting through the dark isn't fully self-sufficient. Part of its chemistry is outsourced to organisms it will never see. Why does most of the planet's land cluster on one side of the globe? Because continents wander, collide, and sometimes gather into a single supercontinent before breaking apart again. Plate motion has assembled and shattered such giant land masses many times over the planet's history in a slow rhythm lasting hundreds of millions of years. Right now, the continents happen to be spread out, drifting between gatherings. The arrangement we treat as the map of the world is just one frame of a film, a momentary pose in a dance that never stops and never repeats. A booster shot works because the immune system rewards repetition. The first exposure to a vaccine builds memory cells, but a later dose does something subtler. It pushes those cells to make antibodies that bind their target more tightly and last longer. Each encounter refines the response, sharpening the fit between weapon and threat. It's learning by drill. The body doesn't just remember the intruder. With every reminder, it remembers better, tuning a defense it may not need to use for many years. Time bends here, but the falling never ends. A wine glass can be shattered by a voice alone, and resonance is the assassin. Every glass has a natural frequency, the exact pitch you hear when you flick its rim. Sing that pitch back at it, loud and sustained, and each sound wave arrives perfectly timed to push the glass while it is already flexing. Just like timing pushes on a swing. The vibrations grow larger with every matched wave until the glass flexes farther than it can bear and cracks. It isn't loudness alone that breaks it. It is energy delivered at precisely the rhythm. A bat can tell a moth from a falling leaf by listening to an echo. It calls in ultrasound, far above our hearing, and catches the returning bounce. A leaf gives a dull, simple echo. A moth's fluttering wings smear the echo with rapid changes, a flickering signature the bat learns to recognize. It even uses the Doppler shift, the rising pitch of an approaching insect, to sense motion. To survive, some moths' evolved ears tune to that exact call and dive the instant they hear a hunter closing in. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world. Double a black hole's mass and you exactly double the width of its shadow. The event horizon scales straight in line with mass because gravity's reach grows in simple step with how much sits inside. This makes the giant strangely roomy. The most massive holes, billions of times heavier than the sun, can have horizons spanning the scale of a planet's orbit. Yet the curve of space across them is gentle. Bigger holes are paradoxically less violent at the edge. Mass and size march together 1 to 1. A rare clean ratio in a universe that loves to complicate. Pluto wears a frozen heart on its surface, a vast, smooth plain of nitrogen ice, and that ice is slowly churning. With almost no craters, this region must be young, constantly resurfaced. Heat seeping up from below makes the ice rise in giant cells, like a pot of soup turning over in slow motion, each cell taking perhaps 1,000,000 years to complete. A tiny, distant world, far colder than anywhere on Earth, is still alive with motion, its frozen plains quietly recycling themselves. Most of the atoms in your body were forged inside stars and scattered by their deaths into clouds like the ones we drift past. Carbon, oxygen, iron, none of them existed when the universe began. They were cooked in stellar cores, then flung outward when those stars exploded or shed their outer layers. That enriched gas seeded new clouds, which collapsed into new stars and planets. You are made of recycled star, processed through generations. Every nebula is both a graveyard and a nursery, and the line between them is matter passing through. A buried sword can hint at the heat of an ancient forge. As blacksmiths worked iron, the way they heated and hammered and cooled it shaped the crystal structure inside the metal. Polish a slice of an old blade, etch it, and look closely, and the grain pattern reveals how hot the metal got and how it was quenched. The smith left no notes, but the steel itself kept a record of the fire. Metallurgy turns a corroded weapon into a transcript of skills passed hand to hand for generations. Why does a single carbon atom always bond to exactly 4 others, never 3 or 5? The number comes from its electron shells. Carbon has 4 electrons in its outer level and room for 4 more, so it can share 4 bonds to fill that shell completely. This precise count of 4 is why carbon links into endless chains, rings, and lattices, the backbone of every living thing. Change the element and you change the number. Oxygen wants 2, nitrogen 3. An atom's capacity to bond is fixed by how many gaps sit. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. There is a hard ceiling on how heavy a white dwarf can be, roughly 1 4/10 times the mass of the sun. Push past it, and the star cannot survive. White dwarfs are held up by the pressure of densely packed electrons, but that support has a limit. Add too much mass, and the electrons are forced to move near light speed, where they can resist no further. Gravity wins and the star either collapses or detonates as a brilliant, oddly uniform kind of supernova. A loaded cargo ship floats while a small steel bolt sinks, though both are made of metal. Floating is not about being light, but about displacing enough water. The hollow hull pushes aside a huge volume of water, and that water pushes back up with a force matching the ship's full weight. The solid bolt shoves aside only its own small bulk, far too little to hold it. Shape a heavy thing wide enough to move enough water, and the sea will carry it. A particular kind of exploding star always detonates with nearly the same brilliance, and that makes it a cosmic yardstick. These stars ignite only when a dead stellar core crosses a fixed mass threshold, so each blast releases a similar burst of light. Knowing the true output, astronomers read the apparent faintness to gauge enormous distances, measuring the reach of the universe one explosion at a time. Field lines are not the same everywhere on Earth. Near the equator, they run nearly flat along the ground. Near the poles, they plunge almost straight down. That tilt, the inclination angle, changes smoothly with latitude. A migrating bird can read the angle and know, roughly, how far north or south it stands, without any sense of east or west. It is a built-in latitude gauge. The same physics that swings a compass needle also tells the bird, silently, how much of the planet still lies between it and its destination. Look closely at an ancient grindstone, and you find what's stuck in its pores. Microscopic plant remains called phytoliths, tiny shapes of silica that plants grow inside their own cells, survive long after the plant rots. Each kind of grass or grain makes a distinctly shaped phytolith, hard as glass and nearly indestructible. Scrape them from the grooves of an old quern or the gaps in old teeth, and you learn which plants were processed there. The food decays, but its glassy skeleton stays to confess the meal. Opal breaks the usual rule of gems. It is not a crystal at all, and its fire comes from structure, not pigment. Inside an opal, microscopic spheres of silica are packed in an orderly array, with tiny gaps between them. Those spheres are spaced about the width of a wavelength of light, so they split white light into its colors, the way a soap film or a butterfly wing does. Tilt the stone, and the flashes shift. Opal's color is not a dye in the rock. It is light itself, bent by an architecture too small to see. You are not, in any simple sense, made of the same stuff you were made of years ago. Skin renews in weeks, the gut lining in days, red blood cells in months, and even the seemingly permanent skeleton trades out its minerals steadily over the years. Different tissues run on different clocks, but the principle is shared. Cells are born, work, wear out, and are replaced, while the pattern they form holds steady. What persists is not the material, but the arrangement. The instructions that keep rebuilding you to the same. Some mountains are flat on top, sheared off as if by a blade, and the blade was time. A flat summit is usually the remnant of an old level surface, a former plain or plateau that was lifted whole. Rivers then carved down into it from the edges, eating away the sides but leaving the original flat top stranded high above. What you see is a survivor, a scrap of an ancient landscape held up while everything around it was cut away into valleys. The same belt of sinking, drying air that bakes the Sahara stretches out over the oceans too, and there it built the world's great wave roads. Under that descending dry air, winds blow steady and reliable across the tropics, always in roughly the same direction. For centuries, sailors leaned on these trade winds to cross whole oceans. So the atmospheric machine that empties the desert sky of rain is the very one that, out at sea, fills a sail. One process, two faces, drought on the land, a free ride on the water. When two black holes spiral together and merge, they ripple space itself. These gravitational waves stretch and squeeze every distance they pass through, including the width of the Earth, by less than the size of a single atom. We feel nothing, yet instruments built around kilometer-long laser beams can catch that faint shiver. The waves carry no light, no matter, only the shaking of geometry. They travel at the speed of light across billions of years, arriving as a brief chirp. Space-time, it turns out, is not a fixed stage. It is elastic, and it rings like a struck bell. Pinch your nose, close your mouth, and food loses most of its flavor. The reason is that most of flavor isn't on your tongue at all. The tongue reports only a few crude signals: sweet, salt, sour, bitter, and savory. The rich detail, coffee, strawberry, smoke, arrives through your nose as aromas drift up the back of your throat to smell receptors. Your brain fuses smell and taste into a single experience and files it under taste. Block the nose and that channel closes, which is why a heavy cold makes dinner taste like cardboard. Ancient scribes wrote with an ink so stable that some texts are still sharp after 2,000 years. Iron gall ink was brewed from oak galls, swellings on trees full of a bitter, acidic compound, mixed with iron salts. The two react to form a dark pigment that does not just sit on the page, but bonds into the fibers, resisting fading and washing. The makers worked by recipe, not chemistry, balancing ingredients by trial. When the exact proportions slipped, later batches sometimes ate through the very paper they were written on. The same reaction, slightly out of coconuts cross oceans. A coconut is wrapped in a thick, fibrous husk full of trapped air, light enough to float for months on open seawater. Inside, a watertight shell guards the seed and a store of fresh water and oil to feed the first sprout. When a current finally washes it onto a distant beach, it can root in bare sand with no soil at all. That is why lone coconut palms appear on islands no one ever planted. The sea itself carried the seed. Color is not a property of light. Light has only wavelength: redness, blueness, the warmth of gold. Those are inventions of the brain. 3 kinds of cone cells in the eye each respond to a band of wavelengths, and the brain compares their signals to assign a color. That's why 2 completely different mixes of light can look identical, and why the same surface can read as one color in shade and another in sun until the brain corrects it. The rainbow you see isn't out in the rain. It's the brain's code for energy your eyes can't otherwise tell apart. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world. Light cannot escape a black hole, yet black holes can shine brighter than whole galaxies. The trick is what happens just outside. Gas spiraling inward piles into a flat, whirling disk, rubbing against itself at near light speed. Friction heats it to millions of degrees, and that searing gas blazes across the sky. The light never comes from inside the horizon. It comes from matter screaming on its way down. So the darkest objects in the cosmos announce themselves with the brightest beacons, fueled not by what falls in. Before refrigeration, builders in hot deserts kept ice through blistering summers using only clay, shade, and the night sky. They poured water into shallow pools shielded by thick walls, and on clear nights the water radiated its heat upward into space and froze, even when the air stayed above freezing. By morning, the ice was gathered and stored in deep, insulated pits. The principle that a surface facing open sky loses heat to the cold of the cosmos was used by intuition long before it had a name. Then the practice faded, only to be the moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. And knowledge is the food of the soul. Plato uses this image in the Protagoras, warning that ideas, unlike bread, are taken straight into the mind with no chance to inspect them first. You can carry food home sealed and consult an expert, a teaching you swallow at once. So choose your sources with care, he urges, because what you learn becomes part of you before you have weighed whether it is good. The wood of an old ship can name the forest it was felled from. Tree rings vary by region, so a beam's growth pattern matches the climate of the place where it grew, not where the ship sank. Compare a hull's timber rings to records from different lands, and you can find the homeland of the trees. A wreck on one shore can show its planks came from forests far away, revealing trade routes and shipyards through the silent testimony of grain laid down before the vessel ever touched water. The waking have one common world, but the sleeping turn aside each into a world of his own. Heraclitus drew a line between shared reality and private dream. Space keeps the line honest. The same star hangs over every watcher on a planet at once. One public fact, while the meaning each mind hangs upon it stays sealed, unshared, turned aside into a world of its own. Some of the oldest writing we have was never meant to be read aloud. The clay tablets of early Mesopotamia are filled with lists of words, animals, professions, gods. Scholars think these were teaching tools, ways to train young scribes by making them copy and memorize. To learn the script, you first learn to organize the world into categories. So some of the earliest libraries were not collections of stories, but reference works, the distant ancestors of the dictionary and the encyclopedia. Built because a writing system complex enough to record speech is also hard enough to require schools. Two crews could meet inside a mountain because the Romans trusted geometry over guesswork. Before digging a tunnel, a surveyor traced the intended line across the surface above, measuring the horizontal distance in any rise. Using the relationship between the sides of a right triangle, he could fix the depth and direction each crew should follow underground. They were in effect solving for an unseen path with marks made in open air. When the two tunnels met in darkness, only a step apart, it was not luck. It was a triangle drawn on a hillside, made real in rock. The gentlest volcanoes erupt almost continuously and rarely make headlines, precisely because of what they release. A shield volcano fed by fluid basalt lets its gas bubble out steadily, so pressure never builds to a breaking point. Instead of one catastrophic blast, it offers long, slow rivers of lava you can sometimes watch from a safe distance. The danger of a volcano, then, is often inversely tied to how freely it can vent. The mountains that destroy cities tend to be the ones that stayed silent and sealed for a very long time. Light from a far cosmic explosion arrives stretched and delayed compared to a closer one, and that difference reveals expansion. Light from a nearby blast comes through quickly. Light from a distant one is lengthened by the growing space it crosses. By comparing how stretched the light is against how distant the source must be, astronomers chart how the cosmos has expanded across its long history. Marcus Aurelius wrote that our life is what our thoughts make it. The mind is not a passive mirror of the world, but the workshop where the world becomes meaning. Each night it takes the raw clay of the day, what was seen and felt and feared, and quietly reshapes it into memory, into sense, into self. We do not merely remember our lives, we build them again and again, in the dark, and wake each morning to a story the sleeping mind has rewritten. He is not lost, he is simply still falling. Fall toward a small black hole feet first, and gravity pulls your feet far harder than your head. The difference stretches you lengthwise while squeezing your sides. A process scientists named, half grimly, spaghettification. It happens because gravity weakens with distance, and near a compact hole that change is brutally steep across even a human body. Around a supermassive hole, the stretch is gentle at the edge. Around a small one, it tears matter apart long before the horizon. The same falling, two fates, decided by how sharply the pull shifts from your toes to your veins have one-way doors. Inside the larger ones, especially in your legs, sit thin flaps that open when blood moves toward the heart and snap shut when it tries to slide back. They matter because veins carry blood under low pressure, often uphill against gravity. The push comes largely from your own muscles. Every step squeezes the veins, the valves channel that squeeze upward, and blood climbs back home. So walking isn't only transport for you, it's a pump for your blood, your legs quietly bailing it back toward your chest. Chili peppers conquered kitchens they had never seen. The pepper comes from the Americas, yet today it feels native to dishes across Asia and Africa. It spreads so fast because the plant is generous. It grows from seed in a single season, tolerates many climates, and its heat helps flavor and preserve food cheaply. Traders carried the seeds, and farmers everywhere found they could grow their own. A flavor crossed the world in mere generations because it asked so little to take hold. The deepest places in the oceans are not in the middle. They hug the edges, long, narrow trenches plunging far below the surrounding seafloor. A trench forms exactly where one plate bends down to dive beneath another. The descending slab pulls the surface into a deep V before it disappears underground. That is why the greatest depths line up with chains of volcanoes and frequent earthquakes. They are all symptoms of the same machinery. A plate folding downward, scraping past its neighbor, sinking into the mantle while the ocean above pours into the groove it leaves behind. A blood clot is not just trapped cells. It is held together by a net you can't see being woven in real time. When a vessel tears, a chain of proteins in the blood triggers one another in sequence, each switching on the next, until the final step converts a dissolved protein into long, sticky threads of fibrin. These strands lace across the wound and snag passing blood cells, turning a loose platelet plug into a tough mesh. The cascade is built to amplify, so a tiny injury sets off a fast, decisive response. Your blood carries a folded blueprint. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. A small iron loop changed how armies rode. The stirrup, a footrest hanging from the saddle, spread westward across Asia along the same corridors as trade. It seems trivial, yet it let a rider brace and stay mounted under impact, fusing horse and human into one stable platform. Ideas like this traveled because traders, envoys, and herders all moved through the same passes. A clever piece of metal needed no translation. Anyone who saw it work could copy it, and so it crossed the world. A wolf can change the path of a river, bring wolves back to a valley, and the elk stop loitering on open riverbanks where they are easy to ambush. Willows and aspens, no longer endlessly nibbled, grow tall again. Their roots bind the soil, beavers return to the thickets, and the channel narrows and steadies. The wolf never touches the water. It can reshape the landscape through fear alone, by deciding where the deer dare not stand. Ecologists call this a trophic cascade. Desert sand is not endlessly old in place. Much of it is the powdered remains of distant mountains. Rivers and ancient floods grind rock into grit and dump it across lowland basins. There the wind takes over, rolling and bouncing the grains until they round off and sort by size, gathering into seas of dunes. Trace a great sand sea backward, and it often points to a long-gone river or a worn-down range upwind. The dunes are a mountain that has been taken apart and laid back down grain by grain. A bird's compass may live inside its eye. In the retina sits a protein that reacts to light, and that reaction is sensitive to the angle of the Earth's magnetic field. The chemistry runs differently depending on how the field tilts across the molecule. If this idea is right, the bird does not feel magnetism as a pull. It sees it as a faint pattern laid over the visual world, brightening or dimming as the head turns. The most invisible force on Earth may show up to a migrating robin as a shadow it can watch. Our sun will not explode. It will quietly shrink into a white dwarf, an ember the size of Earth holding nearly half the sun's mass. The reason is mass. Only stars far heavier collapse violently. When the sun exhausts its fuel, it sheds its outer layers and leaves behind its dense core. No more fusion holds it up. Instead, a quantum rule, the pressure of tightly packed electrons refusing to share the same state, props it against gravity. It will simply cool, fading over billions of years. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Inside a dying, massive star, the elements arrange themselves like the layers of an onion. The reason is temperature. The core is hottest, so it fuses the heaviest fuels, building up to iron at the center. Surrounding shells, each cooler than the one within, fuse progressively lighter elements. Silicon, oxygen, carbon, helium, hydrogen at the outside. The star burns through these layers in a desperate, accelerating sequence. The final stages lasting mere days before the core gives way and collapses. Fix on a small object and quietly notice. Only the very center is in full color and detail. Let your attention drift outward without moving your eyes, and the edges of your view turn pale and vague. The retina's color-sensing cones crowd the center and thin out toward the sides where motion-sensitive cells dominate instead. So your periphery is built for catching movement, not for reading or recognizing hues. The world looks fully colored everywhere only because your eyes flick around so fast that you've sampled color from every spot a moment ago, and the brain assumes it's still there. If we found life on another world, we might not recognize it, because everything we call life shares one ancestor and one chemistry, and we have only that single example to learn from. A different beginning could use different molecules, a different code, even a different solvent in place of water. With a sample size of 1, we can't tell which features of life are universal and which are just Earth's particular accident. The honest frontier is this: we don't yet know what life must be, only what it has been here. Mars hosts a canyon so enormous it would stretch across the width of a continent. Valle Marineris runs thousands of kilometers long and plunges far deeper than the Grand Canyon. It was not carved by water, but torn open by the planet's crust splitting and stretching, a colossal fracture from when the nearby volcanic highlands swelled and pulled the surrounding ground apart. What looks like a river valley is really a wound in the planet itself, a crack so vast it would scar a continent back home. Cool a metal close to absolute zero, and something strange can happen. Its electrical resistance vanishes entirely. A current set flowing will circle for ages with no push to keep it going. Normally, electrons jostle through a metal, bumping atoms and losing energy as heat. But in this cold state, electrons pair up and move in perfect lockstep, slipping past obstacles without scattering. With nothing to slow them, resistance drops to nothing. It is one of the few places in nature where a flow truly costs nothing to sustain. Gravity slows time, and you can feel the difference between your head and your feet. Clocks closer to a Radiation kills mostly by accident. It splits water molecules into hydroxyl radicals, savage fragments that shred the DNA nearby. The tardigrade carries a protein that wraps around its DNA like a cushion, named for suppressing damage. By cloaking the strands, it blocks those radicals from reaching the genetic code. So far, fewer breaks form. The same protein, placed into human cells in a lab, makes them markedly tougher against X-rays. Survival here is not armor against the beam itself, but a shield against the poison water the beam leaves behind. Fresh snow muffles the world into a deep hush, and the silence is built into the snow itself. A fresh snowfall is mostly air, trapped in countless gaps between loose, jagged crystals. When sound waves enter that maze, they bounce among the crystals, losing a little energy with each turn until they fade to nothing, absorbed rather than reflected. A hard surface like ice or pavement would bounce the sound right back at you. Powdery snow swallows it. The quiet after a snowfall is real, a whole landscape turned into a sponge for sound. When a giant star dies, its core collapses in less than a second, falling inward at a quarter the speed of light. The infouling matter slams into the newborn neutron core and rebounds, and a flood of ghostly particles called neutrinos pours outward. Almost all of them pass straight through the star, but enough push back to blow the outer layers apart. That rebound and neutrino blast is a supernova, briefly outshining an entire galaxy of 100 billion stars. Sea ice and land ice end in completely different ways at the coast. Glacier ice forms on land from compacted snow, and where it reaches the sea, it can float out and snap off into icebergs, tall and freshwater pure. Sea ice is different. It freezes directly from the ocean surface in winter and melts back each summer. As salt water freezes, the salt is squeezed out of the crystal, so even frozen seawater becomes nearly fresh. That is why a melting iceberg, born from ancient snowfall, can give you drinkable water in the middle of a salty sea. A supernova can briefly release more energy than the sun will emit across its entire 10 billion year lifetime. The source is gravitational collapse. When a massive core falls inward, an immense store of gravitational energy is suddenly liberated, most of it carried away by neutrinos in seconds. Only a small fraction becomes visible light, yet even that sliver can outshine a whole galaxy. For a few weeks, a single exploding star can be seen across vast stretches of the universe. When Diogenes saw a child drinking from cupped hands, he threw away his only cup. "A child has beaten me in plainness of living," he said. Every possession he could shed was a chain he stopped carrying. Simplicity for him was not poverty, but lightness. Out here, where nothing can be held for long anyway, the traveler learns the same trick, to want only what two open hands can hold. Around a cool red dwarf, the habitable zone hugs the star tightly, far closer in than Mercury orbits our sun. The reason is simple heat. A dim star throws little warmth, so a world must crowd in to stay warm enough for liquid water. But crowding in has a price. That close, a planet often gets locked. One face held toward the star forever, the other in endless night. One hemisphere bakes, the other freezes, and any life might cling to the twilight ring between. Proximity buys warmth, then quietly takes something back. Blow on hot soup and it cools, but not mainly because your breath is cool. The real work is sweeping away the warm, humid air sitting just above the surface. That blanket of moist air slows evaporation, because air already full of water vapor accepts little more. Push it aside with a breath, and fresh, drier air takes its place, letting more soup evaporate and carry heat off. You aren't chilling the soup directly, you're clearing the traffic jam that was keeping its own cooling from working. Almost every large galaxy hides a supermassive black hole at its core, and the hole's mass tracks the galaxy around it. The bigger the central bulge of stars, the heavier the hole, in a steady proportion. This is strange because the hole is tiny compared to the galaxy, far too small to govern its outer stars directly. Yet they grew up together, feeding and shaping each other across cosmic time. The link tells us black holes are not lonely oddities tucked in corners. They are partners in how galaxies are built, woven into the story from the start. Type Ia supernovae explode with such consistent brightness that astronomers use them as cosmic measuring sticks. The reason lies in their trigger. Each begins as a white dwarf that pulls matter from a companion until it nears that universal mass ceiling. Reaching the same critical point, the stars detonate with nearly the same energy every time. Because we know their true brightness, comparing it to how faint they appear reveals their distance, letting us map the scale of the universe. Pour ordinary modern concrete into the sea and the salt water slowly eats it. Roman harbor concrete did the opposite. It grew stronger for centuries underwater. The trick was volcanic ash. Seawater seeped into the mix and dissolved bits of that ash. And from the leftover fluid, new crystals slowly grew inside the empty pores. A mineral called a luminous tobermorite. These crystals knit across tiny cracks like stitches, so the very water meant to destroy the structure kept rebuilding it from within. Decay became repair. 2000, the calcium in your bones and the iron in your blood were cooked inside stars that died before the sun was born. Lighter elements like carbon and oxygen form in the fusion furnaces of aging stars. Heavier ones are scattered when those stars explode, seeding clouds of gas with fresh ingredients. From such enriched clouds, new stars and planets form. You are quite literally assembled from the ash of earlier stellar deaths, a fact that links your body to events billions of years gone. Most of what your eyes send to your brain is thrown away before you ever see it. The optic nerve carries a flood of raw signal, but the brain does not display it like a screen. It predicts what should be there and checks only the differences. Seeing is mostly the brain confirming its own guesses, updating only where the world surprises it. This is why a familiar room appears instantly while a strange one feels effortful, and why we miss obvious things we aren't expecting. Vision is less a recording than a controlled hallucination corrected by light. Place a Geiger counter near an old granite wall and it ticks slowly at random. The stone holds traces of radioactive atoms, and each tick marks one nucleus somewhere inside, choosing this instant to break apart. You cannot predict which atom or when. There is no trigger, no cause to point to, only a fixed probability playing out grain by grain. The clicks scatter unevenly, bunching and pausing, the audible voice of pure chance inside solid rock. It is one of the few places where you can listen directly to the deep randomness woven into the fabric of matter. We cannot dig with care forever, so archaeologists often choose to leave the ground sealed. Once a site is excavated, it is destroyed. The layers can never be stacked back in order. Future scientists may have tools we cannot imagine, able to read clues we would trample blind. So a buried city left untouched is not neglect but preservation, a deliberate gift forward in time. The most respectful excavation is sometimes the one not done, kept whole for hands more skilled than ours. Amethyst is purple quartz, and its color is a flaw, beautifully tuned. Pure quartz is colorless, but amethyst holds a trace of iron locked in its lattice. Natural radiation from the surrounding rock knocks an electron loose around those iron atoms, and the altered iron absorbs certain wavelengths of light, letting violet through. Heat the same crystal, and the color often shifts to yellow as the iron rearranges. The royal purple is not a pigment painted in. It is a few stray atoms and a whisper of radiation, changing how the stone treats light. Never say of anything, "I have lost it," but say, "I have given it back." So Epictetus counseled, "There are no chains in open space, and no possessions either. The ground, the sky, the way home, all handed back. What cannot be returned and so cannot be lost is the steadiness within." Sometimes a fainter second rainbow floats above the first, and its colors run backward. That dimmer bow comes from sunlight reflecting twice inside each raindrop instead of once. The extra bounce flips the color order, so red now sits on the inside and violet on the outside. Each reflection also leaks light, which is why the second bow looks washed out. Between the two arcs lies a darker band of sky, where almost no rays escape toward you at all. Some Viking-age sword blades carry an inscription woven into the steel itself, naming a maker we cannot identify. What sets these blades apart is their iron, unusually pure, with carbon spread evenly, making them both hard and springy. Producing such steel meant melting the metal fully, a feat the makers seem to have managed with imported high-grade material and great skill. When that supply chain and craft lapsed, blades of equal quality grew rare. The know-how was never written down in any way we can read. It lived in hands, and those hands fell silent. The universe has a horizon, much like the curve of the sea hides distant ships. Stand on a shore, and the Earth's bend sets a limit on how far you can see. In the cosmos, the limit is set by the age of light. Beyond it, objects are not blocked by anything solid. They simply lie so far that their light has not yet had the time to arrive. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world, and nearly every atom of gold in existence was forged in catastrophe. Stars fuse hydrogen into helium, then heavier elements, but the building stalls at iron, because fusing iron drains energy instead of releasing it. So how do we get gold, platinum, uranium? In the violence of collapsing stars and colliding neutron stars, free neutrons flood in faster than atoms can decay, building heavier and heavier nuclei. The ring on a finger carries metal assembled in some of the most extreme events the cosmos allows. Now the stranger half. Measure how fast distant galaxies fly apart, and the universe is not just expanding, it is expanding faster with time. Gravity should slow expansion, pulling everything back. Instead, the cosmic stretch is accelerating. Something acts like a pressure woven into empty space itself, pushing outward everywhere at once. We have no light from it, no clump of it, only fresh water floats on salt water, and that simple fact stirs the entire ocean. When sea ice forms near the poles, it leaves its salt behind, making the surrounding water saltier and therefore denser and heavier. That cold, salty water sinks toward the deep sea floor and begins a slow journey across the world, taking centuries to complete a single loop. As it sinks, warmer surface water flows in to replace it. This great overturning is what keeps the deep ocean from going stagnant, and it quietly shuttles heat between the hemispheres for 1,000 years. A drop of water can hold light prisoner. When light inside water meets the surface at a steep enough angle, none escapes. It all reflects back inward, a phenomenon called total internal reflection. Beyond a certain critical angle, the surface becomes a perfect mirror from below. This is why a fish tank's top can look silvery from underneath, and why light races through glass fibers for miles. The light is simply too slanted to break out into the thinner air. The potato quietly reshaped a continent's population. Native to the high Andes, it crossed the ocean to cool, damp northern lands where grain often struggled. And there it thrived, packing more calories into a patch of ground than wheat could. More food from the same field meant more people the field could feed. A tuber bred for thin mountain air became, far from home, an engine of growth. Geography that once limited a region was rewritten by a route that had simply traveled. A flower is an advertisement, and its color is aimed at eyes unlike ours. Bees can't see red, but they can see ultraviolet, and many blooms paint hidden ultraviolet patterns across their petals, invisible to us, blazing to them. These nectar guides funnel the insect straight to the center, where it brushes against pollen on the way in. The plant pays in sugar and gets its genes carried to the next flower. The whole gaudy display exists for one transaction the plant cannot perform itself: travel. A compass needle is a small magnet, and it turns because Earth is a far larger one. Deep inside the planet, molten iron churns and flows, and moving electric charge in that swirling metal generates a planet-wide magnetic field. The field lines run roughly from one polar region to the other, and a freely pivoting needle simply aligns with them, like a straw in a current. North on your compass points toward the magnetic pole, not the spin axis, so the two disagree by an angle that drifts slowly over centuries. On On a steep mountain stream, the water seems to climb itself in a staircase of small pools and drops. This pattern, called step pool, forms because big boulders the flood cannot move snag into ridges, and finer gravel scours out behind each one. The result is a natural set of stairs that slows the water and steadies the slope. The stream builds its own breaks from the rocks it cannot carry, taming the very gradient that gives it speed. On a Greek island long ago, engineers needed to bore a water tunnel straight through a mountain. So they dug from both ends at once and met in the middle. Getting two crews to converge underground, blind, required careful surveying of angles and distances over the surface to keep both headings true. The tunnel they completed still runs through the hill. The mathematics that let them do it was real and deliberate, yet much ancient surveying knowledge later thinned out. And the sheer confidence behind such a feat can feel almost impossible to credit. The asteroid belt between Mars and Jupiter is often pictured as crowded with tumbling rocks, but it is mostly empty space. Spread its objects across that vast region, and they sit, on average, hundreds of thousands of kilometers apart. A spacecraft can pass straight through without ever coming close to one. The belt never formed into a planet because Jupiter's gravity kept stirring the rocks too violently for them to gently gather and stick. So the leftovers remain scattered thin, a ring of debris that never became a world. Black holes come in wildly different scales, yet all obey one rule. Shrink any mass below a certain radius and it becomes one. For the Sun, that radius is about 3 kilometers. For the Earth, a marble. For a mountain, smaller than an atom. The threshold is the point where gravity overwhelms every force that resists it and collapse turns unstoppable. So a black hole is not a special kind of stuff. It is any matter squeezed past its own limit. The recipe is universal. Only nature rarely musters the crushing pressure to follow it. A white dwarf the size of Earth can be hotter than the surface of the Sun, yet it produces no energy at all. The heat is left over. Having ceased all fusion, a white dwarf is simply the exposed, glowing core of a dead star, cooling like an iron pulled from a forge. Because it is so small and dense, it radiates that stored warmth slowly. The faintest, coolest of these embers have been cooling for nearly the entire age of the universe and have barely gone dark. A lump of uranium has a half-life of billions of years, yet you can never say when any single atom will decay. The half-life is not a countdown, it is a probability. Each atom carries the same fixed chance of breaking apart in the next instant, and that chance never changes with age. A million-year-old atom is no closer to decay than a fresh one. So how can the bulk be predictable? Because with countless atoms, the law of averages takes over. Individually random, collectively exact. Half are gone after one half-life, not because any clock ran out. A single thunderstorm can lift a staggering tonnage of water into the sky, and it does so on warmth alone. Sun-heated ground warms the air just above it, and warm air is lighter than the cool air around it. So it rises like a hot air balloon. As it climbs, it cools, and the moisture it carries condenses into towering clouds, releasing yet more heat that drives the column higher still. The storm is a self-feeding chimney of rising air. When the water finally falls, it brings a cool downdraft, and the engine quietly shuts itself off. Most of the helium and carbon you encounter began inside stars through a process of patient assembly. In stellar cores, hydrogen nuclei fuse into helium, and in older stars, 3 helium nuclei collide to form carbon. This stepwise building of heavier elements from lighter ones is how the cosmos grew chemically rich. The earliest universe held almost nothing but hydrogen and helium. Everything more complex, including the carbon in every living thing, was manufactured by generations of stars. The first elements heavier than hydrogen were not made in stars at all, but in the opening minutes of the universe. In that brief, searingly hot window, the entire cosmos acted as a fusion reactor, binding protons and neutrons into helium and a trace of lithium. Then it cooled, and expansion quenched the reactions before anything heavier could form. Every atom beyond lithium had to wait for the first stars to live, die, and seed space with their richer ash. A particular kind of exploding star always detonates with nearly the same brilliance, and that makes it a cosmic yardstick. These stars ignite only when a dead stellar core crosses a fixed mass threshold, so each blast releases a similar burst of light. Knowing the true output, astronomers read the apparent faintness to gauge enormous distances, measuring the reach of the universe one explosion at a time. Bite into something and you can taste savory depth. A fifth basic taste called umami. Specialized receptors on the tongue detect glutamate, an amino acid released when proteins break down, as in aged cheese, ripe tomatoes, or slow-cooked broth. The signal reads as richness, a marker that food carries protein worth eating. It went unnamed in much of the world for a long time, dismissed as merely deliciousness until the receptor was found. Your tongue had a sense we lacked a word for, quietly steering you toward nourishment. The sun pulls on the oceans too, but its tides are weaker than the moon's, and the reason surprises people. The sun is vastly more massive, yet tides depend not on raw gravity, but on how much that pull changes across the width of the Earth. The moon is so much closer that the difference between its near side and far side pull is larger than the sun's, so nearness beats mass. The moon, small and close, stretches the oceans more than the sun, enormous and far. Type Ia supernovae explode with such consistent brightness that astronomers use them as cosmic measuring sticks. The reason lies in their trigger. Each begins as a white dwarf that pulls matter from a companion until it nears that universal mass ceiling. Reaching the same critical point, the stars detonate with nearly the same energy every time. Because we know their true brightness, comparing it to how faint they appear reveals their distance, letting us map the scale of the universe. There is a hard ceiling on how heavy a white dwarf can be, roughly 1 4/10 times the mass of the sun. Push past it, and the star cannot survive. White dwarfs are held up by the pressure of densely packed electrons, but that support has a limit. Add too much mass, and the electrons are forced to move near light speed, where they can resist no further. Gravity wins, and the star either collapses or detonates as a brilliant, oddly uniform kind of supernova. Nearly every atom of gold in existence was forged in catastrophe. Stars fuse hydrogen into helium, then heavier elements, but the building stalls at iron because fusing iron drains energy instead of releasing it. So how do we get gold, platinum, uranium? In the violence of collapsing stars and colliding neutron stars, free neutrons flood in faster than atoms can decay, building heavier and heavier nuclei. The ring on a finger carries metal assembled in some of the most extreme events the cosmos allows. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the sea. A teaspoon of black hole, if you could scoop one, would not have a fixed weight because a black hole's density depends entirely on its size. Small ones are almost unthinkably dense, but the supermassive giants are different. Spread their enormous mass across their enormous horizon, and the average density can fall below that of water. You could not float one in a glass, of course. The point is subtler. Bigger holes pack their mass so loosely that the space inside the horizon is mostly, by ordinary measures, sparse. Density and darkness are not the same thing. The wavy, watered patterns on old Damascus blades were never just decoration. The smiths worked imported ingots of crucible steel, what's melted in sealed clay pots so the iron took in carbon evenly. As the metal cooled slowly, hard carbide particles lined up into faint bands, guided by traces of elements like vanadium in the ore. Forge and etch the blade, and those bands surface as flowing rivers across the steel. The exact ore and recipe were tied to particular sources. When those ran out, the traditional method faded. A single newborn star can carve a cavity light years wide in the cloud that made it. The most massive stars pour out radiation and stellar wind so intense they push surrounding gas away like a snowplow, hollowing a glowing bubble around themselves. The famous pillars in star nurseries are what's left, dense fingers of gas that resisted, shielding darker cores behind them. So a stellar nursery sculpts itself. The first stars to ignite erode the very cloud their younger siblings are still trying to form inside. Here is a humbling fact about flowing water. Engineers cannot calculate the drag on a ship's hull from pure theory. They must test scale models in tanks. The culprit is turbulence, the chaotic swirling that appears when flow gets fast enough. Its hallmark is sensitivity. Nudge the starting conditions a hair, and the pattern of eddies diverges completely. Because tiny causes balloon into huge differences, exact long-term prediction is impossible in practice. So we lean on experiment and approximation. A slow, weightless drift looks orderly. Your skin is not a clean surface. It's a landscape with regions as different as desert and rainforest. Oily zones like the forehead host one set of microbes. Damp folds host another. Dry forearms host a third. Each community is adapted to its patch of moisture, oil, and acidity. And these residents aren't passive. By occupying the skin and producing their own antimicrobial substances, they help crowd out invaders. The body's outer boundary is a living map, defended in part by the very organisms that live on it. When a glowing comb jelly drifts through the water, its shimmer often isn't a chemical glow at all. Rows of tiny beating hairs propel it, and as they move, they split passing light into bands of color, like oil on a puddle. That's a structural effect, not bioluminescence. The same animal can also flash true living light when disturbed. So a single drifting creature can shine two completely different ways. One made by chemistry, the other made purely by the bending of light. You don't have one body temperature, you have two. Your core, the deep organs, is held within a fraction of a degree, while your hands and feet are allowed to swing widely, sometimes cold enough to ache. This split is the strategy, not a failure. The limbs act as a buffer zone, sacrificed to protect the core. In the cold, your body throttles blood flow to the surface, letting fingers chill so the heart and brain stay warm. You keep your essential furnace stable by treating your extremities as a frontier worth losing. Beneath the paving of a Roman road lies something most travelers never saw. A foundation that could run deeper than a person is tall. The Romans dug a trench and filled it in courses. Heavy stones at the bottom for footing, then crushed rock, then gravel and sand, and only at the top the famous fitted paving slabs. Each layer drained water down and away, and spread the weight of carts so the surface would not sink into mud. The visible road was the smallest part. Like an iceberg, its strength was buried, which is why some of these... An echo is just your own voice, returned late, and the lateness measures the cliff. Shout at a distant rock face and the sound races out, strikes the surface and reflects back like a ball off a wall. The delay you hear is the round trip, out to the rock and home again at sound's pace of roughly 1/3 of a kilometer per second. A 2-second echo means the wall is about 300 meters away, not 600, because the sound covered the distance twice. The pause is a ruler made of time. Before paper reached them, the Maya recorded their calendars on folded screens of tree bark, painted in bright colors and read like an accordion. Their timekeeping was built from interlocking cycles, one of 260 days, one of 365, meshing like gears. The two only realign after about 52 years, a span they treated as a kind of century. This let them track immense stretches of time precisely, because combining two cycles of different length creates a much longer one before the pattern repeats. Counting time for them meant watching wheels. A ring-shaped coral island with a lagoon in the middle is the gravestone of a volcano. It begins as a fringing reef hugging a volcanic island shore. The volcano, heavy and cooling, slowly sinks back into the seafloor. But coral grows upward toward the light as fast as the island drops. The peak vanishes underwater. The reef keeps building at the surface. What remains is a ring of living coral, tracing the coast of a mountain that is no longer there. The lagoon marks where a summit used to stand. We are what we repeatedly do. Many credit Aristotle, but the phrasing is the historian Will Durant's, summing up the real idea from the Nicomachean Ethics. Aristotle's own claim, we become just by doing just acts, brave by doing brave ones. Virtue is not a feeling you wait for. It is a habit built by repetition, like a skill. Each small choice repeated quietly carves the person you turn out to be. When a giant star dies, its core collapses in less than a second, falling inward at 1/4 the speed of light. The infouling matter slams into the newborn neutron core and rebounds, and a flood of ghostly particles called neutrinos pours outward. Almost all of them pass straight through the star, but enough push back to blow the outer layers apart. That rebound and neutrino blast is a supernova, briefly outshining an entire galaxy of 100 billion stars. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Twice a month, the tides swing to extremes, and it's a matter of alignment. When the sun and moon line up at new and full moon, their pulls add together and the sea rises higher and falls lower than usual. When they sit at right angles, a week later, their pulls partly cancel and the tides are gentle. The moon sets the daily beat, but the sun, joining or opposing it, swells and softens that beat on a rhythm you can read straight off the moon's phase. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. Migration is not always learned from elders. A young cuckoo never meets its parents. It is raised by another species entirely. Yet when autumn comes, it flies alone to wintering grounds it has never seen, often a continent away. The route and the timing appear to be written in its genes, an inherited program of directions and distances. Hatched knowing roughly which way to go and for how long, it sets off without a guide. The map in this case is not in the memory, it is in the egg. Look closely at Roman concrete and you find little white specks once dismissed as sloppy mixing. They are lumps of lime and they are a repair kit. When a crack opens and water trickles in, those lumps dissolve and react, depositing fresh mineral that seals the gap. The clue was in the method, adding quicklime hot so it scattered through the blend as reactive flecks. For centuries, engineers read those specks as a flaw. Only by studying the chemistry did we realize the ancients had built self-mending stone, then let the technique drift away. Deep inside the mountains of Vietnam lies a cave so vast, a river runs through it and clouds form under its ceiling. Son Dung is wide and tall enough to hold a block of skyscrapers. It grew because rainwater, made faintly acidic by air and soil, seeped along a fault line for millions of years, dissolving the limestone grain by grain. Where the roof grew too thin to bear its own weight, it collapsed, opening skylights. Sunlight poured in, and a jungle took root underground. A forest now grows in a hole carved entirely by patient, slightly sour water. A black hole has no surface. The event horizon is just a boundary in empty space, the radius where escape would require moving faster than light. Cross it falling, and you might feel nothing at all in that moment. Yet outside, that line is absolute. Light itself bends inward and never climbs back out. The darkness you picture is not an object made of matter. It is a region defined entirely by what cannot leave it. The hole is a place, not a thing. A sphere of no return drawn in geometry, not stone. Every star you see is someone who once passed through here. You think you saw the flash and heard the click at the same instant. You didn't. Light reaches you almost instantly, while sound crawls and signals from different senses take different times to process inside the brain. Yet your experience arrives stitched together as one moment. The brain holds incoming senses in a brief buffer and waits, binding events that happen close enough in time into a single now. That window is why distant lightning and its thunder feel like separate events, but a nearby clap and flash feel like one. Your present moment isn't a knife edge. It's the cells that wall off your lungs face a problem most cells never meet, a constant draft of inhaled dust and germs. Their answer is to renew slowly, but defend constantly. The airway lining is studded with cells bearing tiny beating hairs, cilia that sweep a sheet of mucus upward like an escalator, carrying trapped particles toward the throat to be swallowed. When these cells are injured, a reserve of basal stem cells along the airway wall divides to replace them. So the surface meeting every breath is both a moving conveyor and a self-mending tissue. Clearing the air, and the brain runs on roughly a fifth of your body's energy while filling only a 40th of its weight. It has no fuel tank of its own. Neurons cannot store sugar, so they depend on a constant river of blood, delivering glucose and oxygen second by second. Cut that flow for moments and thought falters. Cut it for minutes and cells begin to die. This relentless hunger is the price of a thinking organ, a furnace that must be fed without pause, awake or asleep. Black holes are not eternal. According to quantum theory, they slowly leak particles at their edge and shrink, an effect called Hawking radiation. The mechanism is subtle. The boundary between something and nothing is not perfectly clean, and energy can escape as a faint glow. Smaller holes glow hotter and vanish faster. The largest take longer than the present age of the universe by numbers too vast to picture. But the principle stands. Even the darkest objects evaporate, given enough time. Nothing in the cosmos, not even a black hole, is truly permanent. Coral spawning can paint the sea, as whole reefs release eggs and sperm on the very same night. Many corals can't move to find a partner, so they solve it by timing. Cued by water temperature and the phase of the moon, colonies across wide stretches of reef let go together in a single coordinated release. Synchronizing floods the water at once, overwhelming predators and giving eggs the best chance to meet. The reef turns the night ocean cloudy with life, all from creatures that spend their entire lives bolted in place. A single storm on Jupiter has raged for centuries and could swallow the Earth whole. The Great Red Spot is a hurricane-like vortex wider than our entire planet, and it persists because Jupiter has no solid ground. On Earth, storms die when they drift over land and lose their fuel. Jupiter is all deep atmosphere, with nothing to break the spinning column apart. Bands of opposing winds pen the storm in on either side, like a wheel trapped between two conveyor belts, turning on and on. The pink glow in star-forming nebulae is hydrogen caught in the act of healing. Newborn stars blast out ultraviolet light, fierce enough to rip electrons clean off hydrogen atoms. When a stray electron finds its atom again and drops back down, it releases a very specific red light, a fingerprint of hydrogen returning to wholeness. So those rosy clouds are not lit by reflection. They shine on their own, glowing exactly because they are being torn apart and stitched back together, atom by atom, millions of times a second. Noise-canceling headphones perform a quiet act of subtraction using sound itself. A tiny microphone listens to the rumble around you, and the headphone plays a second wave that is the mirror of it. Every peak flipped to a trough. Where a peak from the world meets a trough from the headphone, they cancel and the air falls still. This is destructive interference. Two real sound waves meeting to produce quiet. Nothing is blocked or absorbed. One wave is answered by its opposite, and where they overlap, the low rumble simply erases itself. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world, and inside a dying massive star, the elements arrange themselves like the layers of an onion. The reason is temperature. The core is hottest, so it fuses the heaviest fuels, building up to iron at the center. Surrounding shells, each cooler than the one within, fuse progressively lighter elements. Silicon, oxygen, carbon, helium, hydrogen at the outside. The star burns through these layers in a desperate, accelerating sequence. The final stages lasting mere days before the core gives way and collapses. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Most of the atoms in your body were forged inside stars and scattered by their deaths into clouds like the ones we drift past. Carbon, oxygen, iron, none of them existed when the universe began. They were cooked in stellar cores, then flung outward when those stars exploded or shed their outer layers. That enriched gas seeded new clouds, which collapsed into new stars and planets. You are made of recycled star, processed through generations. Every nebula is both a graveyard and a nursery, and the line between them is matter passing through. Most of your body's renewal comes down to a small population of cells that almost never specialize. Stem cells, tucked into protected niches in your skin, gut, marrow, and more. They hold a rare power to divide and produce both a copy of themselves and a daughter that goes on to become a working cell. That self-copying is everything. It means the source never runs dry. A skin stem cell can keep generating skin for a lifetime because each division refills the well, even as it sends a cell off to mature. Your continual rebuilding rests on cell. Light from a far cosmic explosion arrives stretched and delayed compared to a closer one, and that difference reveals expansion. Light from a nearby blast comes through quickly. Light from a distant one is lengthened by the growing space it crosses. By comparing how stretched the light is against how distant the source must be, astronomers chart how the cosmos has expanded across its long history. A supernova can briefly release more energy than the sun will emit across its entire 10 billion year lifetime. The source is gravitational collapse. When a massive core falls inward, an immense store of gravitational energy is suddenly liberated, most of it carried away by neutrinos in seconds. Only a small fraction becomes visible light, yet even that sliver can outshine a whole galaxy. For a few weeks, a single exploding star can be seen across vast stretches of the universe. At the heart of our galaxy sits a black hole 4 million times the mass of the Sun, called Sagittarius A. We cannot see it directly, yet we know its weight precisely by watching stars whip around it. Some swing past at a fraction of light speed, tracing tight ellipses around a point of pure darkness. The shape and speed of those orbits reveal the mass tugging on them. Nothing visible holds them, only gravity from something unimaginably dense. The stars are the proof. They circle in emptiness that bends their paths into long. A heavy lorry approaching makes the air carry its low growl long before the engine is in view, and pitch is doing the navigating. Low sounds have long wavelengths that sweep around buildings and over hills with ease, bending around obstacles their own size. High sounds have short wavelengths that obstacles block and scatter. So distance acts like a filter, stripping away the bright, crisp tones and letting only the deep ones survive the journey. Far-off thunder rumbles. Distant music thumps with bass. What reaches you across a distance is mostly the low end, because jump as high as you can, and for a fleeting instant at the top, you are weightless. At the peak, your upward rush has died, and your fall has not yet begun. But throughout the whole leap, nothing has pushed against your feet. Weight is that push, the press of a surface holding you up. The moment you leave the ground, the surface is gone, and gravity alone acts on you. For that brief arc, you are in free fall, an astronaut for half a second. A redwood can lift water higher than any pump should manage, more than 100 meters from root to crown. No heart drives it. Instead, water evaporating from the topmost needles tugs on the column of water in the trunk. And because water molecules cling tightly to one another, the whole thread is pulled upward, unbroken, like sipping through an immense straw. The strain is so great the water is under tension, almost stretched. Among the tallest trees on Earth, the trunk is held up in part by water refusing to let go of itself. Venus is wrapped in clouds that rain sulfuric acid, yet the drops never reach the ground. The surface is so blisteringly hot, around 460 degrees Celsius, that the acidic rain boils back into vapor high in the sky before it can land. This furnace is the work of a runaway greenhouse. A dense blanket of carbon dioxide traps heat so efficiently that Venus is hotter than Mercury, though it sits farther from the sun. Thick air, not nearness, makes it the hottest planet we know. The Romans had no Portland cement and no kilns fired hot enough to make it. Yet their concrete has outlasted much of ours. Their key ingredient came from a volcano. Near the Bay of Naples lies a gritty ash called pozzolana, and when mixed with lime and water, it reacts to form a tough, water-resistant binder, even underwater, where ordinary lime mortar would simply wash away. This pozzolanic reaction let them build piers in the open sea and vast domes with no steel inside to one day rust. The Earth had already manufactured the active ingredient. The Iceland is being torn in two, and that is why it burns. The island straddles the mid-Atlantic ridge, the seam where the North American and Eurasian plates pull apart. Where most of that ridge lies deep underwater, here it coincides with a hot spot, lifting the whole structure above the waves. As the plates separate, mantle rises into the gap, melts from the release of pressure, and erupts as fluid basalt. The country is literally widening, a few centimeters a year, and every new fissure is the planet stretching its skin until it splits. A drying lake doesn't grow its crust evenly. It builds polygons. As the wet salt loses water and shrinks, tension pulls it apart into cracks, and those cracks meet at angles that relieve the most stress, carving the floor into honeycomb tiles. But it doesn't stop there. Salty water keeps seeping up the cracks and crystallizing at the edges, pushing the rims into raised ridges. So the pattern grows and renews itself, a self-organizing mosaic that can stretch to the horizon, each cell roughly the same size as its neighbors. Watch a clock fall toward a black hole, and it appears to tick slower and slower, never quite reaching the edge. This is gravitational time dilation. The stronger the gravity, the slower time runs compared to a distant observer. Near the horizon, the effect grows without limit. Light from the clock stretches redder, dimmer, until it fades from view, frozen in your eyes forever at the brink. The falling clock notices nothing strange. Its own seconds pass normally. Two truths, both real. Time crawls for the watcher, flows freely for the fallen. Wait long enough, and the night sky will slowly empty, galaxy by galaxy. As expansion accelerates, more and more galaxies cross beyond the point where their light can ever reach us again. One by one, the distant ones fade past that horizon and wink out of view. Far in the future, observers will see only their own local cluster, the rest of the cosmos having drifted silently out of reach. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Coral can only build in a narrow ribbon of the sea between sunlight and pressure. It needs light for the algae living inside it, so it cannot grow far below the surface where the water turns dark. Yet it cannot survive being lifted into the air for long, so it cannot build above the waves. That leaves a thin band near the surface where reefs are possible. Everywhere a reef rises today, it is pinned to that band, tracking the exact line where the sea meets the light it needs. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the sea. Quartz crystals so often end in a six-sided point for a reason buried far below sight. Each silicon atom bonds to 4 oxygens, forming tiny tetrahedra, and those units link into a framework with 6-fold symmetry. As the crystal grows, atoms can only attach in ways that honor that underlying order. The visible hexagonal prism and its pointed tip are simply that atomic rulebook, repeated trillions of times. The shape is not decoration imposed from outside. It is the smallest pattern of the mineral, faithfully scaled up until a hand can hold it. Tube worms taller than a person grow around hydrothermal vents, and not one of them has a mouth or a gut. They don't need either. Packed inside their bodies are billions of bacteria that turn the vents' chemicals into food, sharing the meal with their host. The worm supplies raw materials through its blood. The bacteria supply nutrition. Neither could live there alone. A creature with no way to eat thrives in the deep, fed from within by a partner it can never let go. Thinking and being are the same. Parmenides of Elea staked everything on that line, that whatever can be coherently thought must, in some sense, be. He used it to argue that nothing truly comes from nothing. Cosmology echoes the rule it cannot break. Matter and energy are never conjured out of pure absence, only transformed, the books always balancing on both sides of every cosmic change. The center of our galaxy shows itself as it looked when the last ice age gripped Earth. Sagittarius A, the black hole anchoring the Milky Way, sits about 26,000 light-years away. Its glow has been crossing that gulf for 26,000 years. So we observe the galactic heart not as it is, but as it was when mammoths roamed and glaciers spread. Distance turns into deep time. To look toward the core is to peer down a long corridor of the past. Before a tsunami arrives, the sea sometimes pulls dramatically away from the shore, exposing the bare seabed. This happens when the waves trough reaches land first. A tsunami is a long swell with a low part and a high part. And if the low part leads, the water draws back as it feeds the coming crest. That retreat is a warning written in the ocean itself. Animals and a few people who recognized it have moved to high ground in the quiet minutes before the surge returned, far larger than the water that left. Some rivers truly run blood red, and the cause is usually iron. As iron-rich rock weathers, the metal dissolves into the water. When it meets oxygen, it forms rust, the same orange-red oxide that stains an old nail. Suspended in the current, those fine particles tint the whole river. In wetlands, certain bacteria speed the process, breathing iron the way we breathe oxygen. A red river is not poisoned blood, but chemistry in plain sight. Metal meeting air and quietly rusting in the flow. Volcanic ash sounds like destruction, but for archaeology, it is a gift. A great eruption can blanket the land in hours, and that ash layer is nearly identical everywhere it falls. Each eruption also carries its own chemical fingerprint, locked in microscopic glass shards. Find the same fingerprint in an ice core, a peat bog, and a lake bed hundreds of miles apart, and you have strong evidence those distant layers formed in the very same year. one volcano can stitch separate timelines together, linking sites that never otherwise touch. No ground below, no sky above, only the fall. A white dwarf the size of Earth can be hotter than the surface of the sun, yet it produces no energy at all. The heat is left over. Having ceased all fusion, a white dwarf is simply the exposed, glowing core of a dead star, cooling like an iron pulled from a forge. Because it is so small and dense, it radiates that stored warmth slowly. The faintest, coolest of these embers have been cooling for nearly the entire age of the universe and have barely gone dark. A microscopic rotifer can dry to a husk, and as it dries, its chromosomes shatter into pieces. This would doom most creatures, but add water and the rotifer begins to rebuild, stitching the broken strands back together, using its own duplicate copies as a template. Recovery is not instant resurrection. It is repair, hours of careful molecular mending. Over countless cycles of drying and waking, these animals have leaned so hard on fixing genetic wreckage that they have become remarkably resistant to dehydration, surviving by being very, very good. Color is not a property of objects. It is your brain's reading of wavelength. A ripe tomato soaks up the shorter, bluer waves of light and bounces back the long red ones, near 650 nanometers. 3 kinds of cone cells in your retina sample the returning light, each tuned to a different band, and the brain compares their signals to assign a color. The tomato is not red. It is reflecting wavelengths your mind has agreed to call red. Change the cones, as some animals have, and the very same light becomes a different world. The European eel begins and ends its life in the open Atlantic, in a region of floating weed called the Sargasso Sea. Larvae drift thousands of kilometers to European rivers, grow for years in fresh water, then turn silver and swim back to spawn where they were born. They cross an entire ocean with no landmarks. Tagged eels dive deep by day and rise at night, and the pattern suggests they read both temperature layers and the Earth's magnetic field as a map. A creature most people picture in a muddy ditch is, in truth, one of the planet's great ocean voyagers. The moon's glow reaches you about 1 1/4 seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Most of the helium and carbon you encounter began inside stars through a process of patient assembly. In stellar cores, hydrogen nuclei fuse into helium, and in older stars, 3 helium nuclei collide to form carbon. This stepwise building of heavier elements from lighter ones is how the cosmos grew chemically rich. The earliest universe held almost nothing but hydrogen and helium. Everything more complex, including the carbon in every living thing, was manufactured by generations of stars. Sailors learned to read a wind that reversed itself twice a year. Across the Indian Ocean, the monsoon blows steadily one direction for months, then swings completely around with the seasons. A ship could ride it east toward India, wait out the turn, then ride it home. This rhythm turned a vast ocean into a timetable. Spices and cotton crossed it not by luck but by calendar, because the air itself ran like a tide. Whole ports grew around the dates the wind would change. Our sun will not explode. It will quietly shrink into a white dwarf, an ember the size of Earth holding nearly half the sun's mass. The reason is mass. Only stars far heavier collapse violently. When the sun exhausts its fuel, it sheds its outer layers and leaves behind its dense core. No more fusion holds it up. Instead, a quantum rule, the pressure of tightly packed electrons refusing to share the same state, props it against gravity. It will simply cool, fading over billions of years. A snake's tongue isn't for tasting in the way ours is. It's for smelling in stereo. Flicked out, the forked tip collects scent particles from the air and ground, then slots them into two pits on the roof of the mouth called the Jacobson's organ. Because the fork has two tines, the left tip can gather a stronger scent than the right. The snake compares the two sides just as we compare loudness between our ears and turns toward the stronger trail. A split tongue becomes a compass pointed at prey. Stomach acid is strong enough to eat through some metals, yet your stomach digests itself only rarely. The trick is a coating. Cells lining the stomach secrete a thick layer of mucus, and beneath it, bicarbonate, a base that neutralizes acid right at the wall. The acid stays in the cavity, doing its work on food and killing most swallowed microbes, while the lining hides. Glass beads were once a currency of ideas. Along ancient routes, small, worked glass beads turn up thousands of kilometers from where they were melted because they were compact, durable, and desired everywhere. To trade a bead was to trade a sample of a distant workshop's skill. Where the beads went, the appetite for that craft followed, sometimes the craft itself. The humblest object in a caravan could carry the reputation of a city no one in the receiving market had ever visited. The fig and its wasp cannot live without each other, and the proof is a death. A fig is not really a fruit, but an inside-out garden of flowers, sealed in a pod. A female wasp squeezes through a pinhole entrance, tearing her wings off in the process to pollinate the flowers and lay her eggs. She dies inside. Her offspring hatch, mate, and the new females fly off carrying pollen to the next fig. Many fig species have their own wasp, locked in a contract written over tens of millions of years. A bone under steady stress quietly grows stronger exactly where the load falls. The reason is that bone cells can feel force. Trapped inside the hard mineral are osteocytes, sitting in fluid-filled spaces, and when the bone bends, that fluid shifts and tugs at them. They read the tug as a signal. Build here. Where strain is high, more mineral is deposited. Where bone goes unused, it is dissolved away. This is why the racket arm of someone who plays tennis for years carries denser bone than the other. The skeleton listens to how you move and rewrites itself to match the life it is asked to live. Run the laws of motion backwards and the future becomes as fixed as the past. Physics at its core plays no favorites with time. So why can you scramble an egg but not unscramble it? The answer hides in scale. A single molecule's path is reversible, but an egg is trillions of molecules, and the scrambled state can be realized in countless more ways than the neat one. Reverse the egg, and you'd need every molecule to retrace its steps in perfect lockstep. Overwhelmingly unlikely. The arrow of time, strangest of all, emerges from laws that don't contain it. A red blood cell is shaped like a disc pressed in at the center, a tiny dimpled cushion, and that shape is engineered by absence. Because the cell ejected its nucleus while maturing, nothing bulges in the middle, leaving a thin, flexible center. That dimple does real work. It gives the cell extra surface area for trading oxygen, and it lets the cell bend and fold to squeeze through capillaries narrower than itself, springing back to shape on the other side. A cell that kept its nucleus could never deform so freely. The most common cell in your body owes its clever form to what it gave up. In the warm Pacific, navigators read the ocean with their skin and trained that skill on land first. Out on open water, a master could lie in the hull and distinguish several swells crossing at once. The steady old swell from a distant storm, a fresher one from local wind. Each had its own rhythm and push against the body. Knowing the reliable direction of the dominant swell, he held course by feel, even when cloud hid every star. The sea itself, pressed against the ribs through thin wood, became a steady, readable compass. The highest excellence is like that of water, says the Tao Te Ching. The excellence of water appears in its benefiting all things and in its occupying, without striving, the low place which men dislike. Lao Tzu's water wins by yielding. Watch a drifting figure settle toward the lowest orbit, the way a river always seeks the sea. Many gemstones are the same mineral wearing different colors. Ruby and sapphire are both corundum, a crystal of aluminum and oxygen. Pure corundum is colorless. Swap a few aluminum atoms for chromium, and the crystal absorbs green and blue light, glowing red as a ruby. Trade in traces of iron and titanium instead, and it drinks other wavelengths and shines blue as a sapphire. The hard lattice stays the same. Only a sprinkle of impurity changes. Two famous gems, one mineral, separated by a handful of stray atoms tucked into the grid. The matter spiraling into a black hole releases energy far more efficiently than the fusion that powers stars. As gas falls through the steep gravity, it surrenders a large fraction of its mass as a pure radiation, a much greater share than burning hydrogen ever yields. That is why feeding black holes shine so fiercely. The light is the toll matter pays to fall in. Deep gravity wells convert mass into energy with brutal effectiveness. Pound for pound, nothing lights the cosmos more economically than something simply falling toward a place it can never leave. Helium fills a balloon and lifts it, while ordinary air pulls it down. The lift is a matter of atomic weight. A helium atom is tiny and light, far lighter than the nitrogen and oxygen molecules crowding the air around it. Pack a balloon with helium and it weighs less than the air it shoves aside, so the heavier air slides under and pushes it up. It floats for the same reason a cork rises in water. The surrounding fluid is denser. The balloon does not defy gravity. It simply loses a contest of weight, atom against atom. Strip away the soil gently, and the dirt still holds the shape of things long rotted. A wooden post decays, but the hole it stood in fills with darker earth, leaving a stain. A vanished body can leave a void in hardened ash that is filled to recast its final pose. Even a buried ditch reads as a different color from the ground around it. Archaeologists often excavate not objects, but absences, the dark prints of what is gone. The soil keeps a kind of negative photograph of structures that crumbled to nothing. Whisper at the curved wall of certain old halls and someone across the room hears you perfectly, while people between you hear nothing. These are whispering galleries, and the secret is the shape. A smooth curved surface reflects sound much as a mirror reflects light, and a circular wall keeps bouncing the wave along its inner edge instead of letting it spread and fade. Your faint whisper clings to the curve, hugging the wall the whole way around, and arrives at the far side still intact. The room doesn't amplify you. It refuses to let your voice scatter. Mix two gases in a box and they spread evenly, never spontaneously separating back into two halves. Nothing in the underlying physics forbids the reversal. The molecules could, by chance, all drift apart. It simply almost never happens, because the mixed arrangement has astronomically more possible configurations than the sorted one. This is entropy, not a force, but a tally of probabilities. The reason you have never seen a puddle leap back into a cup is purely statistical. The universe isn't pushed toward disorder. It merely stumbles into the overwhelmingly likely again and again. For a telescope cannot easily photograph a planet, and the reason is brightness, not distance. A star can outshine its planet by a factor of millions, like trying to spot a firefly hovering beside a lighthouse from kilometers away. The planet's feeble glow drowns in the star's glare. So to see worlds directly, instruments must blot out the star with a precise mask, holding back its light so the faint companion beside it can finally emerge. Most of what we know about distant planets, we learned without ever seeing them at all. Why are auroras green lower down and red far above? It comes down to how patiently each oxygen atom glows. When solar particles excite oxygen, the atom can release green light in under a second, but the red glow takes a couple of minutes to emerge. Lower down, the air is dense, so an excited atom bumps into a neighbor and loses its energy long before the slow red light can escape. Only the quick green survives. Far higher, the air is so thin that collisions are rare. The atom waits undisturbed and the lazy red light finally shines. Fungi do not eat the way we do. They eat the world from the outside in. A fungus pushes its threads into wood or leaf litter and releases enzymes that dissolve the material around it into a soup of simple molecules. Then it soaks those molecules back up through its surface. There is no mouth and no stomach. The digestion happens outside the body, in the soil itself. By rotting the dead this way, fungi unlock nutrients held in fallen trees and return them to the living forest. A Roman cup in a museum looks dull green by daylight, then glows wine red when lit from inside. The Lycurgus cup does this because its glass is laced with flecks of gold and silver only billionths of a meter across. Those flecks scatter the light that bounces off the surface, yet let a different color pass straight through, so the hue flips with the lighting. The makers could never have explained it. The effect lives in matter too small to see. The skill to produce such glass reliably did not survive, and the science behind it arrived nearly 2,000 years late. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world. And Mars has 2 tiny moons, and one of them is doomed to fall. Phobos orbits so close and so fast that it laps the planet several times a day, faster than Mars itself turns. Because it circles below a certain critical distance, the planet's gravity is slowly reeling it inward. In the far future, it will either be torn into a ring of rubble or crash into the surface. Unlike our own outward drifting moon, this little world is spiraling down toward the planet it has circled for ages. Your heartbeat doesn't come from your brain. It begins inside the heart itself, in a cluster of cells in the upper wall that leak electricity in a slow, steady rhythm. Each leak builds to a spark. The spark spreads through the muscle and the heart contracts. Cut every nerve to the heart and it keeps beating, which is exactly why a transplanted heart works at all. Your brain only nudges the pace up or down. The drumbeat itself is local, automatic, and older than thought, set by a pacemaker of living tissue. Some stars you admire tonight may no longer exist. Light from a distant sun can take thousands of years to cross the gap to Earth. If such a star burned out a millennium ago, its final light is still in transit, still painting a point on your sky. You would go on seeing it shine faithfully until that last wave of light swept past. The star is gone, but its image lingers, a candle whose flame we still watch long after the wick is cold. The calcium in your bones and the iron in your blood were cooked inside stars that died before the sun was born. Lighter elements like carbon and oxygen form in the fusion furnaces of aging stars. Heavier ones are scattered when those stars explode, seeding clouds of gas with fresh ingredients. From such enriched clouds, new stars and planets form. You are quite literally assembled from the ash of earlier stellar deaths, a fact that links your body to events billions of years gone. Most of your serotonin, the molecule tied to mood, isn't in your brain. It sits in your gut. The lining of your intestine makes the great majority of the body's supply, using it to control how the gut squeezes food along. This is one thread of a constant conversation between belly and brain, carried by a thick nerve running between them. Strikingly, most of that traffic flows upward, gut reporting to brain. So the hunch that your stomach has moods of its own isn't only poetry, it's a genuine chemical dialogue. Why is gold yellow when most metals are silvery gray? Strangely, the color comes from Einstein's relativity. In a heavy atom like gold, the inner electrons orbit so fast they gain extra mass and pull inward, shifting the energy levels of the outer electrons. That shift lets gold absorb blue light rather than reflecting everything evenly. Remove the blue and what bounces back to your eye is warm and yellow. Silver, lighter, keeps its electrons slower and reflects all colors alike. Gold's glow is a rare case where a glass of ice water can stay at 0 degrees for a surprisingly long time, even in a warm room. As long as solid ice and liquid water sit together, the temperature holds steady at the melting point. Every bit of heat sneaking in from the room is spent melting ice, not warming the liquid. The temperature won't budge until the last sliver of ice is gone. A melting mixture is a natural thermostat, which is why crushed ice was once the trusted way to fix a known cold temperature. A pot of boiling water sits stubbornly at 100 degrees Celsius, no matter how high you crank the flame. The extra heat doesn't raise the temperature. It goes entirely into tearing molecules free from the liquid and turning them to steam. This hidden cost is called latent heat, energy spent changing state rather than warming. The same accounting works in reverse. When steam condenses on your skin, it dumps that stored energy back, which is why a steam burn is far worse than hot water at the same temperature. Some of the strangest life on the planet eats rock and breathes metal. In sediments and crust where there is no oxygen, certain microbes pull energy from iron, sulfur, or stone, running a chemistry our bodies never use. They reveal how broad the rules of life really are, and they hint at how living things might survive on worlds without sun or air. We keep finding them precisely where we assume nothing could persist. Each deep sample rewrites the boundary of the possible. The frontier here is not a place so much as a question: where exactly does life end? Far out in the open ocean lies a forest with no floor. The Sargasso Sea is named for sargassum, a brown seaweed that floats in golden rafts on the surface, kept aloft by tiny gas-filled bladders along its fronds. Rotating ocean currents ring this region and gather the weed into a slow, calm gyre, so it drifts and reproduces without ever touching land or seabed. Eels travel thousands of kilometers to spawn there, and crabs and fish live their whole lives in the drifting weed, a woodland adrift on water. Close your eyes and touch your nose. You found it instantly. But how did you know where your nose was with your eyes shut? A hidden sense, sometimes called the body's sixth sense, reports the position of every limb without sight. Tiny gauges woven into your muscles and joints sense stretch and tension and stream that information to the brain, which assembles a constant inner map of where you are in space. It runs silently in the background, which is why you can climb stairs in the dark or scratch an itch behind your back without ever looking. Send a probe falling into a black hole, and from a safe distance, it never seems to arrive. Its light stretches and dims as it nears the horizon, and the image slows, reddens, and finally fades, appearing frozen just shy of the edge for all time. From the probe's own view, the crossing is quick and uneventful. It sweeps past the boundary in moments. Both pictures are correct. Gravity stretches the light's wavelength and stalls the signal so severely that the distant observer's clock and the falling probe's clock can no longer agree on a simple question: when did it fall in? Strike-slip faults grind sideways, and they can slice straight through the landscape like a knife through layered cake. The two blocks slide horizontally past each other, so a river, a fence, or an ancient road that once ran in a single line ends up offset, its halves carried apart by meters with each great quake. Geologists read these displaced features like a logbook, measuring how far the ground has jumped over thousands of years. The crookedness in the land is the fault signature, the visible sum of countless invisible lurches. The first elements heavier than hydrogen were not made in stars at all, but in the opening minutes of the universe. In that brief, searingly hot window, the entire cosmos acted as a fusion reactor, binding protons and neutrons into helium and a trace of lithium. Then it cooled, and expansion quenched the reactions before anything heavier could form. Every atom beyond lithium had to wait for the first stars to live, die, and seed space with their richer ash. Lifting a multi-ton stone block was only half the problem. The other half was grabbing it. The Romans solved this by cutting a tapered slot into the top of the stone itself and dropping in iron pieces called a lewis, wedge-shaped bars that splay apart inside the slot as the rope pulls up. The harder you lift, The tighter the iron jams into the stone. The grip comes from the weight it is carrying. Set the block down, the iron loosens, and you lift it back out. A stone could be hoisted by a hole drilled into its own body. A sundial in summer and a sundial in winter disagree, and for centuries that was fine. The shadow of a vertical stick swings through the day, longest at dawn and dusk, shortest at noon. By marking where the shadow falls, you read the hour from the sun's position, but the sun climbs higher in summer and lower in winter, so the same dial gives different readings across the year. People lived with this drift because their day was anchored to noon, the moment the shadow points truest, when the sun sits highest in its arc across the sky. An ordinary main sequence star is oddly good news for life because it does so little. Such a star fuses hydrogen at a steady patient rate, holding its brightness nearly constant for billions of years. That long calm matters. If life needs deep time to arise and grow complex, it needs a sun that won't flare wildly or burn out fast. Hot, massive stars blaze bright but die young, too quick for biology to unfold. The unremarkable, long-lived stars, the patient ones, may be exactly the kind that give life enough time. The movement of the Tao by contraries proceeds, the Tao Te Ching says, and weakness marks the course of its mighty deeds. Lao Tzu sees creation cycle back to its source. So does the universe. Atoms forged in stars scatter, settle, and gather again into something new. Atmospheric pressure isn't abstract. It's the weight of air stacked above you, and it's heavier than it feels. At sea level, a column of air pressing on a single square meter weighs about as much as a small car. You don't feel it because the same pressure pushes from inside your body and from every side, balancing out. Climb a mountain and there's less air overhead, so the pressure drops and the air thins. The ocean of gas you live at the bottom of has a real and measurable weight. Look closely at undisturbed desert ground, and the dark, crusty surface between the stones may be quietly alive. It is a living skin of microbes, lichens, and tiny organisms, glued together with their own threads. This crust grips the soil so the wind cannot scour it, and it pulls nitrogen out of the air to feed the rare plants that follow. Built over decades, it can be crushed by a single footstep and take a human lifetime to heal. The desert's toughest defense against blowing away is almost too delicate to touch. A teaspoon of the sun's core would weigh nearly a kilogram, heavier than a brimming pint of water packed into a single spoon, because matter there is crushed to extraordinary density. Deep inside, the immense weight of the sun's outer layers presses down with crushing force, squeezing the central gas far denser than any metal. That pressure and heat are exactly what fuse hydrogen into helium, releasing the energy that lights our days. The sun shines not despite being squeezed, but because of it. Gravity itself lights the furnace at its heart. Most of the living ocean is not the bright surface, but a vast dim middle, and its stage is one of the largest movements of animals on Earth. Every night, countless small creatures rise from the deep toward the surface to feed, then sink back before dawn to hide from predators in the dark. They do it because light means danger, so they trade safety below for food above on a daily commute. This twilight zone is so big and so poorly sampled that even the total mass of fish living there is uncertain by huge factors. The planet's busiest, look outward and you look backward, which means there is a horizon to what we can ever see. Because the universe has a finite age, light from beyond a certain distance simply hasn't had time to reach us yet. Past that edge, galaxies surely exist, but their light is still on the way or may never arrive. This boundary isn't the edge of space, it's the edge of the observable, drawn by light's speed in the age of everything, a curtain set by time, not by walls. A black hole is described by just 3 numbers: its mass, its spin, and its electric charge. Nothing else survives. Throw in a star, a planet, a library of books. Once it crosses the horizon, every detail of what it was is erased from the outside. Physicists call this the no-hair principle, the idea that black holes have no distinguishing features. 2 holes with the same mass, spin, and charge are truly identical, however differently they form. The cosmos keeps an astonishingly short record. Whatever falls and leaves behind sprinkle iron filings around a magnet, and they leap into looping arcs, drawing a picture of something invisible. Each filing becomes a tiny compass, twisting to align with the magnetic field at its spot, and end to end they trace the field lines. The lines crowd together near the poles, where the field is strongest, and spread wide between them. Nothing is actually flowing along those curves. They are a map of direction and strength, the otherwise unseeable shape of the force a magnet pours into the space around it. Seneca wrote a single line that has outlived empires. It is not that we have a short time to live, but that we waste much of it. His point was mechanical, not poetic. A life is long enough for great things if none of it leaks away on distraction. Watch the figure drift here, and the math feels honest. The clock never slowed for anyone. We simply spend the hours, then call the bill unfair. Cross certain deserts at dawn and you might find a thin crust glittering with dew. Then watch tiny beetles drink it. In the coastal Namib, fog rolls in off a cold sea most mornings. Some beetles climb a dune and tilt their backs into the breeze. Water vapor condenses on their hard shells, beads up, and trickles down channels straight to their mouths. They never see rain, yet they harvest the air. In a place defined by absence, life learned to squeeze a drink out of a mist. A planet can sit in the habitable zone and still be a frozen rock or a furnace. The zone only marks where a star's warmth could let liquid water survive on a surface. Close enough not to freeze, far enough not to boil. But water needs more than the right distance. It needs air to hold the heat and press down on the liquid. Mars rides the outer edge of our sun's habitable zone, yet its thin atmosphere lets surface water boil away or freeze solid. The zone is an invitation, never a promise. It tells you where to look, not what you'll find. Dark energy hides a paradox. As space expands, ordinary matter thins out, so its gravity weakens. But the dark energy density seems to stay constant. More space simply means more of it. So a push that was once overwhelmed by matter's pull grows relatively stronger as the universe dilutes. Early on, gravity won and expansion slowed. Then, as matter spread thin, the push took over. We live after that turning point, in the age when emptiness itself sets the pace. Other rivers glow in almost unreal milky turquoise, and the color comes from grit too fine to see. Glaciers grind the bedrock beneath them into a flower of microscopic mineral particles called rock flour. When meltwater carries this powder into a river, the grains stay suspended rather than settling. They scatter sunlight, bouncing back the blue and green wavelengths while absorbing the rest. The result is that luminous, milky blue. The river's strange color is really crushed mountain, hanging weightless in the water. There is an old image of teaching as kindling a flame, not filling a vessel, and it captures the method of Socrates exactly. The phrasing traces to Plutarch, who wrote that the mind is not a jar to be filled, but wood that needs lighting. Socrates poured no facts in. He asked questions until the answer caught light in the other person's own mind. Learning on this view is ignition, not storage. A good teacher does not hand you the fire. They strike the spark and step back. A supernova can briefly release more energy than the sun will emit across its entire 10 billion year lifetime. The source is gravitational collapse. When a massive core falls inward, an immense store of gravitational energy is suddenly liberated, most of it carried away by neutrinos in seconds. Only a small fraction becomes visible light, yet even that sliver can outshine a whole galaxy. For a few weeks, a single exploding star can be seen across vast stretches of the universe. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited. On a still night, a sound from across a lake can reach you with startling clarity, and the air itself is bending it. After sunset, the ground cools fast, so the air near the surface turns colder than the air above. Sound travels slower in cold air, and a wave slows on its lower edge while its upper edge races ahead. That tips the whole wave downward, curving it back toward the ground instead of letting it escape upward. The night doesn't make sound louder. It bends the sound back down to you. Montaigne kept returning to one quiet aim. The greatest thing in the world, he wrote, is to know how to belong to oneself, not to rule others, not to gather more, but to own the one mind that volcanoes mostly line up, and that alignment tells you what is happening underground. Trace the great volcanic belt around the Pacific and you are tracing plate boundaries, places where ocean floor dives beneath the rim of a continent. As the slab sinks, it releases water into the hot mantle above, which melts, rises, and erupts. The volcanoes follow the boundary because the melting follows the slab. Where plates simply slide past each other, with no diving, there are far fewer eruptions. The pattern of fire is really a map of where the planet's surface is being pulled apart or pushed under. At the close of each day, Seneca would put himself on trial, asking what fault he had cured and in what way he was better. With no nights and no days out here, that ledger still waits, for the only audit that ever truly mattered is the inward one. Some seeds will not sprout until a fire has passed. In fire-prone scrub and forest, certain plants lock their seeds inside woody cones or hard shells sealed with resin. Only the intense heat of a wildfire melts that seal, springing the cones open to scatter seed onto freshly cleared, ash-fertilized ground, with rivals burned away. The plant has turned the very thing that kills it into the trigger for its next generation. In these places, fire is not the end of the forest, but its appointment with renewal. There is a hard ceiling on how heavy a white dwarf can be, roughly 1 4/10 times the mass of the sun. Push past it, and the star cannot survive. White dwarfs are held up by the pressure of densely packed electrons, but that support has a limit. Add too much mass, and the electrons are forced to move near light speed, where they can resist no further. Gravity wins, and the star either collapses or detonates as a brilliant, oddly uniform kind of supernova. A spider sits at the center of its web, not just to wait, but to listen. The silk is a sensory instrument. When an insect strikes a strand, the impact sends vibrations racing along the threads to the spider's legs. Different threads carry the tremor at different speeds and strengths, so by comparing what reaches each leg, the spider judges direction, distance, and even the size of the catch. A struggling fly hums differently from a wind-blown leaf. The web is not only a trap, it is an ear spun from silk, stretched across the dark. Some coastlines get 1 high tide a day, others get 2. The difference comes from the shape of the ocean basin the water sloshes within. Tides are vast, slow waves, and like water in a basin, they rock back and forth at a rhythm set by the basin's size and depth. Where that natural rhythm matches the daily pulse, you get a single tide. Where it matches the twice daily pulse, you get 2. The moon supplies the push, but the bowl beneath the water decides how the answer comes out. Table salt is a mineral, and it grows in tidy cubes for a reason you can taste but never see. Salt is sodium and chlorine, and their ions carry opposite electric charges. They arrange themselves so each sodium sits surrounded by chlorines and each chlorine by sodiums, alternating in a perfect 3-dimensional checkerboard. That balanced grid meets the world at right angles, so the crystal ends in flat square faces and sharp corners. A cube. Pour salt into your palm and look closely. Those little cubes are electric attraction made solid. A wave-cut platform, that flat shelf of rock revealed at low tide, is the floor left behind as a cliff retreats. Waves attack a cliff hardest near the waterline, undercutting it until the overhang collapses. The cliff steps back. A newborn spends close to half its sleep in the dreaming state, far more than an adult. In the womb in the first months, REM sleep floods the developing brain with internally generated activity, Waves of firing that sweep through circuits not yet shaped by the outside world. This self-made stimulation appears to help wire the visual and motor systems before experience can. The dreaming brain may be rehearsing itself, building its own scaffolding in the dark before the senses arrive. Look at the sky through polarized sunglasses and slowly rotate them, and a band of sky darkens. Sunlight scattered by air molecules becomes polarized, its waves vibrating mostly in one plane, and the effect peaks at a right angle to the sun. A polarizing filter blocks waves of one orientation. Aligned against that scattered light, it dims a whole stripe of sky. The blue overhead is not just colored, it carries a hidden grain that the right filter can read. A single great river can quietly behead a mountain range. As a river cuts down into rock, it works backward up its own valley, gnawing toward the high ground. Given enough time, it can saw a deep gorge,